abantu bandiphila ngesilo eyazayi kaphela kwalenza ngaba abantu. Okay, we are back. Yo, okay, yeah. I guess we are back. The situation made us leave. We had to leave, unfortunately, and we are only now back. And those who may have probably been here but ended up having to leave because I left, I'm very sorry that I abruptly had to end the live. It's just that there was something that was calling for my attention, and had I not attended to it, it would have been serious problems. So I'm just glad that yeah, let's just say one thing, everything is in order, thankfully. Okay. All right. So yeah, we were busy with grade 12 build-up lesson on nature of roots and functions, and we basically merging the two topics. So I just want to revert back to what I had started saying at the beginning. We had first spoken about the nature of roots, and specifically we were still unpacking what are roots. We'd established that roots are solutions of an equation. They are critical values. They are also x-intercepts. Solutions of equations, critical values, x-intercepts. They are solutions of equations when there's an equation, of course, all right? So when you solve an equation, let's say you have x plus 3 is equal to 0, then basically you say x is equal to negative 3. Okay. So we call that a equation, the solution of an equation. Then we say roots are also critical values, all right? And obviously that's where your inequalities are concerned. There's a place where you actually write down critical values, and your critical values are actually your the same things as your solutions of an equation. Then last but not least, roots are also referred to as our x-intercepts, okay? And specifically most in a graph where the function cuts the x-axis, which is usually there and there, we know those are our x-intercepts. Okay. Wow, thank you for asking. Thank you for asking. You are definitely right. There was a noise. Like I said, something really disturbed me. There was a bit of fright that basically was invoked by something. All right, and I had to attend to it because I thought we were under serious, danger or something. So it just so happened it was something minor, but of course to an individual it might not be as minor. So we attended to it. Let's just say it's not as serious as I perceived it to be. But thank you so much for actually checking up on that. I really appreciate it. Okay, Yeah, there's definitely people here in the live, and I'm hoping that over time, what will happen is that I can sift out, the people that are, because some of you people are here simply because you want to get something from me, right? And you can see by how people comment in the comment section. It's like someone will say, when are we doing grade 10 maths and physics? When are we doing this? When are we doing that? And people, you are like, give me, give me, give me. But I think there are people that I can genuinely see here. It's like, they are here, they are very modest about it. They ask questions when they have to. And you can see there's sort of like an understanding that behind the camera there's a person, and therefore the person, we need to be mindful of that. So thank you so much. I really appreciate those who are genuinely here with a heart that, would speak of humanity. But there are people here that are just like, hey, this guy is a machine, is an object. He just needs to give me what I need to get from him, and then thank you so much, and then we can move on to the next thing. All right, so thank you so much for asking about that. Really appreciate it. I wish I knew your name, but I'll call you the whale man, because I see a whale that is characteristic of your TikTok name. Anyways, so like I was saying, those are roots, okay, under different headings. Then I was talking about the nature. What is the nature? When we say what is the nature of the roots, we are wanting to find out the roots that we get. How are they? All right. And so we can look at that under three headings. The first one is we need to determine whether the roots are real or non-real. So I said, if they are non-real, we know that means simply that there is no solutions of the equation. It also means there are no critical values, and it also means there are no x-intercepts. That's how we interpret non-real, okay? Non-real means there is no real solution. There is no real solution. So within the framework of the grade 12 syllabus, if you are doing CAPS, all right, you are just limited in your understanding up until that extent. Other things, like for instance, greatest op mentioned in the comment section. What about complex numbers? Guys, you are going to go into that more deeply in the university space. I know that, for instance, learners from Zim that do A levels and O levels, they get into that, whilst they are still in high school. And that is the beauty of their syllabus. And some people that do advanced maths and add maths and all these other things, they'll probably share more. But for us, those who are writing their trial exams for under CAPS, okay, we know that non-real, would infer that we have no real solutions in the equation, we have no critical values, and also we have no what? X-intercepts. Okay. Okay. You see such comments. For instance, there's a guy who just came in, and I just want to show his comment. There it is. Okay, there it is. These are people I don't need in my life. They need to vamos. They need to vamos. They need to vamos. They need to vamos. But I see that guy has no followers, so I'm guessing it's just his mission to come into lives and say funny things. Okay, so non-real means that, guys. So when we have non-real roots, we know it's non-real, full stop. We stop right there. We can't say anything further. We stop right there. I mean, if there's no solutions, it means we can't say more about what it does not exist. I mean, the solutions are not there, so what can we say about them? They are non-real, full stop. The roots are non-real, and that's it. Done, finished, full stop. Then there's another category that we can speak on as far as our roots are concerned. We can say the roots are real. The roots are real. Now, under roots that are real, I want to then extend then the next ring of headings that we can speak on. If we discover that the roots, guys, are real, we can then distinguish as to whether are the roots rational or are the roots irrational. And so if you remember, just before I left the live, we were trying to define what a rational number is. And what had been said is that a rational number is a number that can be written as a fraction, where your numerator, which is a, and your denominator, which is d, are both elements of integers. I repeat, they are integers. Your what? Your a and your b. Your numerator and the denominator are both what? Integers. But b can never be 0. Because the minute the denominator is 0, we know that the fraction is what? If the fraction, the denominator has 0, what do we know about that particular fraction? Can we still say the number is rational if the denominator is 0? What do we say about the fraction if the denominator is 0? All right. So greatest ops is undefined. Okay, and I hope we all understand that if the denominator is 0, indeed the fraction is undefined. Okay. Now integer numbers are numbers that are positive and negative whole numbers. Okay, so the numerator and the denominator need to be integer values, positive and negative what? Whole numbers. So when we say the roots are real, we can either say they are rational, or the opposite to that is that they are irrational. And an irrational number, guys, I'm just going to give you an example. For instance, all numbers that are irrational are numbers that are under an even root and they are non-perfect square. Okay, non-perfect square. Okay, so 2, for instance, this number here is a non-perfect square number. All right, it's a non-perfect square number, the square root of 2. On the other hand, the square root of 4 is a perfect square number and it qualifies as an irrational number. Okay, the number 4 underneath the square root is a perfect square, and the answer you get for the square root of 4 is what? Is 2, and 2 can be written as 2 over 1. So any perfect square number that is underneath a square root, we refer to it as a rational number. But if it's a non-perfect square under a square root, then of course it's a irrational number. Okay, no problem, Michaela. Okay, so I hope that makes sense here then, guys, that when we say roots are real, we can either then piggyback on they are real and rational, or we can say they are real and irrational. But that all depends on whether the roots are really those roots irrational, or are those roots actually irrational. So it depends, okay, on that particular situation. The last thing we comment on when it comes to roots, okay, and the understanding we have here is that we are dealing with a quadratic equation where we expect or anticipate that we will have 2 roots for our particular what? For our particular equation. So those roots can either be both rational, or we can say they are both irrational. Okay, operating of course under the real banner. They can be rational or irrational. And then the last thing we can comment on is the fact that those roots can either be equal, which means we have the same roots, okay, or the same x-intercepts, or the same critical values, or, sorry, not the same, because if we're saying unequal, it means they are not the same roots. Okay, my mistake there. Unequal means not the same. I mean, if you are unequal, it means you are not looking the same. It's not the same roots. But equal means we have the same roots. Okay, I hope we are together here. All right. So, guys, this, in a nutshell, is what we understand when it comes to nature of roots. What are roots? I'm going to repeat again. Roots are solutions of an equation. We can also refer to them as critical values where inequalities are concerned, and also we can refer to them as x-intercepts where we have our function. Okay. Then, when we speak about their nature, we are looking at those numbers that are represented as our solutions, our critical values, and our x-intercepts, and we want to check whether are these roots real. And remember, what did we say real is? Real numbers are just simply numbers that exist in our number system. All numbers that exist in your number system are called real numbers. It's the entire family of numbers. That is what real numbers are. On the other hand, non-real numbers are numbers that are not real. Okay, so they are real numbers, but they are non-real numbers. Okay, if we want to then explain non-real in terms of our roots, what does that mean? Non-real in terms of our roots means, one, there are no solutions to our equation. Two, in terms of inequalities, it means that there are no critical values. Three, non-real means for our functions, there are no x-intercepts. That's what the word non-real means. Okay, very important, very, very important. Then we look at real. Real, like I said, means all the numbers in the number system. If we then go to the next ring of explanation for real numbers, we can divide real numbers into rational and irrational numbers. We've explained what rational numbers are. Okay, all numbers that can be written as a fraction, where the numerator and the denominator are integers, are called rational numbers. An example of that is when we have a perfect square number underneath a square root. That perfect square number underneath a square root is a clear example of a rational number, because the square root, for instance, of 4 gives you 2, and 2 can be written as 2 over 1. So this indeed is a what? A perfect square number. A perfect square number written underneath a square root is a rational number. An irrational number, on the other hand, is a non-perfect square number. Okay, if it is written underneath a square root, of course, then it is irrational. Okay, very important that we note that. Then lastly, our roots can be unequal, meaning they are not the same roots, or they can be equal, meaning we can get the same roots. Okay, and it's very important, very, very important what we note here. Okay, so I hope this is clear for us. So in grade 11, what they start doing to us is that at the beginning of the grade 11 syllabus, they first expose us to this formula. Do we all know what this formula is, guys? What do we call this formula? What do we call this formula? Do we all know what this formula is? I can see the hands typing very fast. Someone is like punching, making sure that they get the answer first. Okay, this formula we all love and know it, and we call it the what? The quadratic formula. Okay, so very good. You guys have defined it well. This is the quadratic formula. Okay, and I'm sure all of us, we love using the quadratic formula to solve for all equations when we are given an equation to solve. But now I want you to note something for me very quickly. In nature of roots, they actually come to this part of the formula. This part of the formula, this one. Okay. What is this part of the formula referred to? This part. This expression. The b squared minus 4ac. Okay. Because they actually extract that part. Okay. And the greatest op there has said it well. The Greek symbol is called delta. This is the symbol that is expressing the expression b squared minus 4ac, which we refer to as the discriminant. Yabo. Some people say it is the one that discriminates. Okay, it discriminates as the discriminant. So b squared minus 4ac, all right, is a shortcut method that helps me and you to what? To find the nature of roots of any quadratic equation without solving that equation. Without solving the equation. So the discriminant is a shortcut method that does what? It helps me do what? Helps me and you to what? To find the what? The nature of the roots of any what? And specifically, guys, of any quadratic equation. Please, guys, take note. A quadratic equation, not a linear equation. Discriminant is not used to find the nature of roots of a linear equation. It is not used to find the nature of roots of a cubic equation. It is used to find the nature of roots of a quadratic equation without having to solve that particular equation. Now people are being like, what do you mean without having to solve the equation? All right, let me give you an example. Typically, if I was given, let's say, an equation that is x squared plus 5x plus 6 is equal to 0, first and foremost, do you guys see what this equation, what type of equation it is? Can you tell me what type of equation this is? X squared plus 5x plus 6. Can you categorize what type of equation x squared plus 5x plus 6 is equal to 0 is? Okay. Are we all in the same boat in understanding what type of equation this is? Thank you so much, Mvika. Mvika is spot on. This is a quadratic equation. Listen to me and listen to me very well. I can solve for x for this equation. What do I mean when I say I can solve for x for this equation? It means I can find the roots. Solving for x means finding the roots of this equation. Are you with me, guys? Solving for x means finding the roots of this equation. Well, let's go. Let's solve for x for this equation. My equation currently is in standard form. So what I do is I factorize. Okay, the factors of 6. This is positive, so that means my signs will be the same inside the bracket according to the sign of the middle term. So I have plus and plus. Then the factors of 6. When I multiply, give me 6. When I add, give me 5. What are those factors? Is it 6 and 1? Is it 3 and 2? Which one qualify? 6 and 1, 3 and 2. 6 and 1, 3 and 2. What do the masses say? 6 and 1? 3 and 2. Which one? 6 and 1? 3 and 2. Nwa Masaseka, hi Ndlambi, says 3 and 2. And so do the rest of the amazing jury say so as well. Okay, spot on, guys. I'm proud of you. There are my factors. After getting my factors, having seen the standard form of the quadratic equation, I can now use the zero factor law and write down the individual equations that are linear. This is applying the zero factor law. Factors equated to zero, factor equated to zero. I can do that. It's called the zero factor law because there's a zero on the other side and the product of factors. Then my roots, my R for roots. X is equal to -3 or X is equal to -2. This is solving the equation. I can, if I want to, comment on the nature of my roots. I'm going to ask you guys, this first is my X is equal to -3 and this is X is equal to -2. I want to comment on the nature of these roots. How are these roots? First question, are the roots real or non-real? This is the first root, it's -3. The second root is -2. Are the roots real or non-real? Please comment in the comment section for me. Are the roots real or non-real? Are the roots real or non-real? I am observing what you guys are typing there. Okay, and I want you to check something here very quickly, very quickly. Check. Do you see what my good, beautiful friend Michaela said there? Do you see the pinned comment? Michaela is saying the roots are non-real. Now let's read the rest. Everybody else, okay, Eli is also saying non-real. Ale, Mr. Nobody is saying non-real. Destin is saying non-real. Selo is saying non-real. Senande is saying non-real. So there's a handful of people that are saying non-real. Greater Stop is saying real. Olu is saying real. Ches is saying real. Some others are saying real. So we have divided views about the roots. Listen to me, guys. Listen to me like you've never listened to me before. Please, guys. Look at this number. This is the value of X. This is a root. This root is -3. And this root is -2. Are these numbers that exist in a number line? Do they exist in a number line, these two numbers? Okay, do these two numbers exist in the number line? Are they numbers that exist in the number line, -3 and -2? Yes, they do. Thank you very much. I hope you guys understand what I'm asking. -3 and -2 are roots that exist in a number line. In other words, they exist. They both exist. So I'm going to ask again, is -3 as a number and -2 as a number real or non-real? Let's give people a chance again. Let's see if the comment section will be the same instead of having differences. Grateful is saying real. Greatest Love is saying real. Mtokos is saying real. Sarah is saying real. Ivile is saying real. Born again is been born again, saying real. Olu is saying real. Noah, Mimi, real. Thank you. You know, you guys now are officially on board, except this man here. Okay, Briley is killing me softly with his comments. Briley said this in the beginning. Briley 2K is saying this still. Briley is brilling me out. He's brying me and he's brilling me. He's grilling me right now. Guys, the roots are real. -3 and -2 are real numbers. What did we say are real numbers? Real numbers can either be rational or irrational. Rational numbers can be written in the form of a over b. We said the number 2 is a real number. Here we have the two roots, -3 and -2. This here means these are two real numbers. So therefore, the roots here are real. Please, please, please. Okay? There's no square root over the -3, because if there was, then we would definitely say this is non-real. If there was a square root there under the -2, then we would say definitely it is what? Non-real. Okay? So I hope you guys understand what I'm saying here. So when we comment, we can say the roots are real. Definitely. We have two additional rings of commentary that we need to make. The next part, are the roots, since they are real, are they rational or are they irrational? Are the roots rational or are they irrational? In other words, -3 and -2, are they rational numbers or are they irrational numbers? These two numbers, -3 and -2, just -3 and -2 alone. No square root, no nothing. -3 and -2, are those two numbers rational or are those two numbers irrational? You can see the comment section. We still have division in understanding. Hey, Bana. Hey, Bana. Hey, guys. What are going on in this life? Hey, Bana. -3 as a number. John, look at this. -3 as a number and -2 as a number. Are these two numbers rational or irrational? Guys, we said that a rational number is a number that can be written as a fraction. A over B, in other words, where A and B, the numerator and the denominator, are what? Are integers. Now I'm asking, -3 as a number. Can't -3 as a number be written as -3 over 1? And can't -2 be written as -2 over 1? Aren't these two numbers rational? Hey, Bana. Hey, Bana. Hey. Mutimontate. Ay. Booyah. You must come back. Things are they are going south here. Okay. So my two roots are rational, guys. These are rational numbers. Then the last thing I want to say, the last thing I want to conclude, are these two roots equal or are they unequal? These two roots, are they equal or are they unequal? Okay, -3 and -2, and I love the comment section because majority is saying unequal. -3 and -2 are not the same. Remember, what did I say here? Unequal means not the same roots. Equal means the same roots. What you are finding here is two roots that are not the same. So we say the roots are unequal. Now I need you guys to listen up. What did I now in front of your eyes do? I have just done something that you guys probably, when you have done nature of roots at school, you did not typically start by unpacking first. What is a root? What do we mean by it? What is the nature? What do we mean by it? Then unpack for you. Okay, shortcut of determining nature of roots? Discriminant. Why do we use discriminant? Shortcut method that helps me and you to find the nature of roots of any what? Quadratic equation. Without what? Very important part, this one. Without solving the equation. But then I'm like in my head, what if we decided to solve the equation? So I come here, I solve the equation. Let's just for a moment solve the equation x squared plus 5x plus 6 is equal to 0. And go ahead and get our roots. Okay, remember we said the solutions of x are roots. So we have x is equal to -3 or x is equal to -2. These are roots. Can we just comment on these roots that we found here? Because what we are doing here is we are determining the nature of roots by solving the equation, getting the solutions of the equation and then commenting on them. All right. So -3 and -2, are they real numbers or non-real? So we did say, oh, the roots are what? Are real. Okay. Then 2. -3 and -2, are they rational or irrational? Oh, the roots are rational. -3 and -2, are they equal or unequal? Yes, the roots are unequal. Okay. So this is determining the nature of roots by solving the equation. But we know we have a shortcut, and our shortcut is just using the discriminant. So I'm going to use the very same equation, but this time round we are going to use the discriminant. Okay, we're going to use the discriminant and investigate the nature of the roots. Okay, so now let's use the discriminant and then determine the nature of roots. We are still dealing with the same equation, x squared plus 5x plus 6, because we want to check something. Okay, same equation, no different. So what is the procedure whenever we are using the discriminant? The first step is that any equation you are given, you must make sure that that equation is in standard form. We must make sure the equation is in standard form. Then step number 2, we must identify from that standard form equation A, B, and C. What do we mean by A, B, and C? Remember, standard form means ax squared plus bx plus c is equal to 0. So our A value, the coefficient of x squared, our B value, the coefficient of x, our C value, the constant value. So what is A according to this equation? A is equal to, not all together, come on, I know you guys are so you're so ready to type in the comment section and tell me what A is and B is and C is so that we can have this sorted. A is equal to 1. Thank you so much. You guys are phenomenal. What is B? What is B? The value of B. Okay, very good. What is C? What is C? All right, you guys are awesome. Okay, after identifying A, B, and C, okay, step number 3, I write down my delta and substitute the A, B, and C. So let's write down the formula for delta, or the discriminant, b squared minus 4ac. Then let's substitute. B is 5 in brackets, please. In brackets when you substitute, please. Minus 4 times 1 times what? C, which is 6. 4ac. B squared minus 4ac. 5 squared, 25. 4 times 1 times 6, negative 24. 25 minus 4, 1. So delta is equal to 1. The 4 is in the formula of the discriminant. B squared minus 4AC. This is the formula that we got from the quadratic equation underneath the square root. Okay? So that's where the 4 comes from. It is the discriminant. B squared minus 4AC. So this 4 comes from there. A, C, B. All right? B squared, 5 squared, 25. 4 times 1 times 6 with the negative. Negative times a positive, negative 24. What's 25 minus 4? 1. Question. Tell me about delta. Value of delta. Tell me about delta. Now there are two things. Delta firstly is greater than 0. The number 1, guys, is a number that is greater than 0. Do we all agree? Right? 3. Delta is my favorite chocolate. I hope it's yours too. Delta is my favorite chocolate. Is it your favorite chocolate or not really? Delta is my favorite chocolate. No, I'm just kidding, guys. Delta is a... What does this PS stand for? Anyone? Anyone know what PS stands for? I just wrote that for short because I could see that I'm running out of space. Delta is a positive. Okay, of course delta is positive, but I mean I've already covered that by saying delta is greater than 0. When I say delta is a PS, what kind of number is that? Evile, you are the girl. Evile. Delta is a perfect square. Guys, this is very key, right? So when I answer the question, determine the nature of roots, this is a typical question. They could either say to you, discuss or determine or determine the nature of roots without solving the equation. Without solving equation. What? Discuss or determine the nature of roots without solving the equation. So whenever I'm asked to discuss or determine the nature of roots without solving the equation, these are my steps. The equation that is given to you, write it in standard form. Identify A, B, and C. Substitute into delta. Write down your formula of delta. Substitute into delta. Get your value of delta. Get your value of delta. Comment on roots from delta. Comment on the roots from delta. Listen to me, guys. Listen to me. I'm cooking here. I'm cooking. Delta is equal to 1. The value of delta is greater than 0. Do we all agree? Yes. Delta is also a what? A perfect square. This number 1 is a perfect square number. That's why we are saying delta is a perfect square. It's a perfect square number. So, seeing that is the case, what does that mean about my roots? Are the roots real or non-real? Let's start there. Are the roots real or non-real? Okay, thank you so much. They are real. What informs the fact that the roots are real? Here is it. The fact that delta is greater than 0. This thing here is the one that informs that the roots are real. Delta greater than 0 means that the roots are real. Hey guys, delta greater than 0 informs the fact that the roots are what? Are real. Okay. Do you know why, guys? Do you know why in my head we know that if delta is greater than 0, it informs that the roots are real? It's because in the back of my head, I know that this expression is an expression that is actually situated where? Underneath a square root. Underneath a square root. This value here, the discriminant, it's an expression, which means this value is a value that we know is located underneath the square root. So the minute this value here is greater than 0, it means that my roots are real. Full stop. Okay. Let's move on to the next thing. If they are real, I said we can comment under 2 more rings of comment. The second part, are the roots rational or irrational? And where do you get that from? Are the roots rational or irrational? Born again says rational. Born again has been born again like for real. No joke. The roots are rational. Now the thing is, the reason why we say the roots are rational comes from this important point here, that delta is a perfect square number. Perfect square number. My authority to say the roots are rational comes from the concept of what? Of the delta value being a perfect square number. That is why I can confidently say the roots are rational. Then the last part, are the roots equal or unequal? And where does the confidence to say so come from? Okay, I have different comments in the comment section. There are those who are saying unequal. There's a person who's saying equal. But it seems in the majority so far, people are saying unequal. And I want to join the bandwagon of those that are saying unequal. Why, guys, are we saying unequal? Because delta is greater than 0. It is not equal to 0. The reason why we say unequal is because delta is greater than 0. It is 1, which is a number that is greater than 0. That's why we can confidently say unequal without any hesitation. Guys, hey, this is important. So do you see why I write my roots are real? Real is informed by delta being greater than 0. Rational is informed by the fact that delta is a perfect square. Unequal is informed by the fact that delta is greater than 0. Okay, are you with me? Hey, I hope you are with me, guys. Bongani Nkosi, what kind of question are you asking me? Bongani Nkosi, what kind of question? I hope Bongani Nkosi could come here. You know, Bongani, come here. Bongani, come here. You must accept now my request. I've extended a request to Bongani Nkosi. Bongani Nkosi, come here. You must come and talk to me so that we can. You must talk to me. What are you saying now? Why is the answer 1 but not mine? Since it is under a square root. Why is the answer 1 but not -1? Yeah. So Bongani, you can have extended an invite to you specifically. Accept the invite, my brother, so we can speak. 24 minutes past 12. You can speak to me. So I need you to clarify what you mean. Right. Now, some of you are probably sitting there and you're like, okay, sure, okay. Why did you waste our time here then, sir? solve the equation, get the roots, write down the roots, and comment. I just wanted you guys to see that getting the nature of roots you can get the nature of roots by solving the equation. You get your roots and then you can comment on what you see, because these are the roots. -3 and -2 are the actual roots that you end up commenting about when you are finding your discriminant. It's just that in this situation, you are speaking to delta, and delta is informing the roots, right? But what can you see? What did we say about the equation? We said the roots are real, rational, and unequal. You see, when we use delta, still the roots are real, rational, and unequal, which means what we did here was 100% correct. Okay, but Tina, whenever we are asked a question and it says discuss or determine the nature of roots without solving simply means please don't waste anybody's time. Use delta. Finish. All right. Okay. It means you use delta. Finish and clear. If they say discuss or determine the nature of roots without solving the equation, this is what it means without solving the equation. You write your equation in standard form, you identify A, B, and C, you substitute into delta A, B, and C, you get the value of delta. When you get the value of delta, please tell me what you see from delta. Is delta greater than 0? Is delta a perfect square or not? When you write these things will help you to be able to then conclude about the roots. What you see here will tell you there. What you see there will tell you about this. And what you see there will tell you about that. So as long as delta is greater than 0, you will always be able to 1, 2, 3. Okay, and if delta is not a perfect square, had this value been not a perfect square, the only thing that would have changed is what? Is rational. It would have changed to irrational. Okay. Hey, guys, that is the first type of question you can get under nature of roots. You can get the question that says determine or discuss the nature of the roots. And your steps to discussing or determining the nature of roots, very simple. You write your equation in standard form, you identify A, B, and C, you write down the formula of delta, you substitute A, B, and C in it, you get the value of delta, then you comment based on delta about the what? About the roots. Okay, so we're going to do some more examples so that you guys can appreciate the seemingly basic approach. So let's say we have another question: discuss the nature of roots. Guys, I'm still dealing with the first type of question you can get. There are 2 more types of question you can get under nature of roots, and I'm going to deal with them in this live. Okay, so for now, I'm still dealing with the first ring of questions. Discuss the nature of roots without solving. Remember, when they say without solving, shortcut method, guys. Without solving the equation just means shortcut delta. All right, we don't waste time. Okay. So let's check this one out. Let's say we have x squared minus 5x sorry. Let's say minus 6x plus 9 is equal to 0. Right, so once again, we need to discuss the nature of roots for this one. We're going to look at another one and another one, just so that we can get a full experience of these questions and understanding. So remember, first step, equation must be in standard form. Is it in standard form? Definitely yes, it is. Step number 2, identify our A, B, and our C. So in the comment section, just tell me what all 3 values are. Don't write them individually. Tell me what all 3 values are: A, B, and C. What is A? What is B? What is C? Let's see in the comment section if we can get a correct, consistent answer for everyone. No one must comment if they are not sure. Comment only if you are 100% sure about what the value of A, B, and C are. Write them all so that we can see that we've got this. A is equal to B is equal to C is equal to all three of your values of A, B, and C. What are they? Okay, Noah has started off for us. I see your answer, Noah. Masaseka. Okay, and it seems like Noah is the only one that basically is eager to comment. It seems like everybody else has just lost their mojo. All right. Okay, so I guess I'm gonna go with Noah in this particular segment or situation. Okay, we have Livia who's commented as well. Noah fixed something. Spinara is also having commented. T has commented. Okay, so we can see that most are saying A is equal to 1. Okay, B is equal to -6, and C is equal to 9. Yeah, so sorry guys, I'm sorry about what seemingly does not look clear. That was 6. Okay, so you guys are 100% spot on. The next step, we write down delta. Delta is equal to B squared minus 4AC. Then we do what? We substitute. So B, -6 squared. 4AA, 1C, 9. Okay. Then what do we get? 36 minus 36. So delta is equal to what? 0. Okay. All right. Okay. So here we have delta and it's equal to 0. So what then do we have to say if delta is equal to 0? Okay. If delta is equal to 0, what can we say? First and foremost, delta is equal to 0, and what else? Delta is a, you guys will be very shocked, is a what? Is a PS. It's a PS, Baba. It's a PS. All right. And it's very funny that people are saying the roots are real, rational, equal. Okay. So equal to 0, just like greater than 0, also means delta is, the roots are real. I repeat, delta equal to 0, just as delta is greater than 0, both mean that the roots are real. Very important conclusion there. 0, guys, we regard it as a perfect square. So therefore the roots would be rational. It falls on and tends to lean on rational. Okay, so that's why we say rational, the roots, because delta is a perfect square. And then lastly, delta, since delta is equal to 0, we say that the roots are equal. It's only equal to 0 that basically helps us conclude that the roots are equal as well. We never say equal as far as the roots are concerned until delta is actually equal to 0. Okay. Flowing? Good. Understanding? Okay, I hope our understanding is very clear there. I really hope so. I really, really pray it is. Okay. Next one. Discuss the nature of roots for this one. X squared plus 6 is equal to 0. Okay, so first and foremost is the equation in standard form. Okay. Is it in standard form? Okay. Yes, it is. So what is our value of A, B, and C? A, B, and C. Do we see it? The value of A, B, and C there? Okay, Livia says A is equal to 1, B is equal to 0, and C is equal to 6. Do you agree with Livia? I think I tend to agree with her wholeheartedly and completely. Then we use delta is equal to B squared minus 4AC. We substitute. Then final answer 0 minus 24, which is equal to a negative 24. Delta is equal to a negative 24. Now, what does that mean? It means that delta is less than 0. Full stop. Hey, guys, we don't write this full stop, but I'm making a point. I'm making a point. I am making a point. All right. Please, guys. Delta is equal to negative 24. We just say delta is less than 0. And then the roots. What about the nature of the roots? Thank you so much, Sinoyol. So kind. Thank you so much. Delta is equal to negative 24. Delta is less than 0. So the roots are what? Are non-real, exclamation mark, done, full stop. Guys, are you feeling me here? Yo, hey. This is big. This is big, big, big. If you are not flowing with us here, then you are gonna have the problems here. Okay, right? Now, some of you, I know what you did. You know, some of you may have said delta is less than 0. Delta is irrational. Oh yeah, guys, listen to me well. When delta is less than 0, okay, think about it, right, as I explained it earlier on. Remember when I said to you, if we say that the roots are non-real, okay, it basically means there are no solutions of the equation. There are no roots, in other words, no x-intercepts. The graph does not cut the x-axis. Okay. I repeat, no roots, no solutions of the equations, no x-intercepts. Okay, so if delta, guys, is less than 0, okay, you will remember I said no solutions, we stop right there. Stop right there. How can you comment further about something that does not exist? Okay, I'm just asking a question, guys. There are no real solutions, but when you want to say, after saying the roots are non-real, in other words, after saying there are no solutions, you've said that there are no solutions. Okay? Yes. So after saying there are no solutions, you want to comment further about something that is not there. You want to say about these solutions, these x-intercepts that are not there, you want to comment further and say they are irrational, and they are unequal, or they are equal. How can you say anything more than that? Okay, so when we say delta is less than 0, the roots are non-real. Full stop. Done. Finished. We can't say anything more. So my advice then to you is that the minute you have a negative number for delta, remember this b squared minus 4ac is in actual fact a value that is underneath a what? A square root. Okay? So we say delta is less than 0, but the roots specifically, it means that they are non-real. There are no real solutions. So we can't then say more about something that is non-real. Okay? Guys, are you feeling me here? Because if you are not, yeah, we stop there. Okay? Yeah, within the realm of the work that we are doing, we stop there. Okay? Those who are eager to go to varsity and do more, don't worry. When you go to varsity, you'll get exposed to more, right? Okay. Any questions from anyone? Okay. Yes, Livia. Yes, Livia, I think you're having an aha moment. It's very important to have these aha moments. Okay. I hope these aha moments will further, sink deep down within the very fibers of your being, so that it informs what you do in the future. Okay. We can't afford to be butchering or making mistakes where we always used to make mistakes. We need to grow and we need to flourish and be better, so that we don't get affected in the future. So those are type 1 of the questions we get for nature of roots. And I just want to suggest something to you here, that given these solutions that you have here, if we were to have a graphical representation of what we mean here, all right? Remember, I said here the roots are real, rational, and equal. Okay. A graphical representation of this would be when the roots are real, rational, and equal. Okay. Remember, when we say the roots are real, it means those are x-intercepts that are there. They exist. They are rational, the x-intercepts. And they are also what? They are equal. Meaning there's only one solution. All right? So a graphical representation of that would be something like this. I just want you to see this. This would represent equal roots, okay, that are real, of course. Okay, obviously this function, the coefficient of x squared is positive, so that means it's a smiley face. Okay, and the x-intercept, there's only one x-intercept, because if the roots are equal, it means there's only one solution of x. In other words, there's only one x-intercept that exists for that happy function. Okay, because the thing is, you need to relate this nature of roots back to what? To functions. We need to understand that in light of functions, this quadratic equation, which can be written as an expression, x squared minus 6x plus 9, can be drawn as a function where we can see clearly that, oh, there's one x-intercept. This is what real, rational, and equal roots, especially this thing, equal roots, means. It means there is one root or solution, one x-intercept. So that x-intercept, it coincides with our turning point for our quadratic equation, right? Okay, I hope that makes sense. Monosi, like I said, we need to calm down, but I see what you're saying. Okay, that is a function after all. Okay, and it qualifies as many to one. And then x squared plus 6 is equal to 0. All right, remember this one. If we were to sketch this function, okay, this is like a grade 10 function where you have this representing the y-intercept, okay, and that y-intercept would also represent the turning point. But remember, we said there are no real roots. In other words, there are not going to be any x-intercepts. So what are you expecting with this function? You're expecting a function that basically does not even touch the x-axis. This here is what non-real roots looks like. When a, the coefficient of x squared, is positive because it's a smiley face, concave up. So this is non-real, guys. This is graphically, this is what non-real looks like. Okay? Roughly, this is what non-real. No real solutions. No x-intercepts, in other words. Guys, that's why I was explaining these things in the beginning now, saying, if you say non-real, it means no what? No x-intercepts, no critical values, no solutions of that particular equation. In other words, there are no x values. Okay, and graphically you can see that when you draw a quadratic function. Oh, this one does not cut across, cut the x-axis at all. All right. Okay. Then let's go and check out our brother here. I can do that, Monos. If you look at this brother here, x squared plus 5x plus 6 is equal to 0. This guy here, right? Remember, we had actually found the x values here, right? This particular one would be a function like this. I mean, we found the x-intercepts. They were -2 and -3. So -2 and -3 are on this side, okay? But what we find about this is that unequal roots basically mean you have two x-intercepts, right? Two distinct x values. The word distinct comes into play because unequal roots also means distinct. If let's say I say Ivile is distinct from Maths is a game, then it means that we are different, separate, and apart. We are not the same. Okay? Right? So I hope you guys understand this integration of nature of roots together with what? With functions. So, okay. So I hope this makes a bit more sense in light of what I've done, because today I did say to you that I'm going to merge, I'm going to try and actually integrate nature of roots with what? With functions. So that our nature of roots, when we do nature of roots, it's not like we are doing nature of roots not knowing, you know, what it may sort of mean for our functions. Okay, I'm going to look at type 2 now of nature of roots type questions. Okay, so I've just given you a nice hot roundup of nature of roots type 1, and then you could see graphically how it would look like when we're talking about roots are non-real, obviously no x-intercepts. Roots are equal, it means one x-intercept. But then if we say roots are unequal, it means two distinct roots. Okay, two different roots. Distinct means different, means unequal. So these are just words, guys, English words that basically mean the same thing. Synonyms. You call them synonyms, right? I think that's what they call them in English. Yeah. Type 2. This is a past paper from Gauteng province. Okay, trial exam paper. Look at this question here. And this is a question that is asked in grade 11. This is a typical grade 11 question, but it's been put in this trial paper and it was asked to the learners. Okay, now we are jumping into type 2. Okay. The solutions of a quadratic equation are given by state the values of p for which this equation will have two equal solutions for 1 mark, no real solutions for 1 mark. All right, let's look at it again. This is applicable to both 11 and 12. This is a grade 11 question. It's not even grade 12. Grade 12s have a bulk of their work being asked from grade 11. So if you are in grade 11 and you don't really care, okay, about what it is that you are doing in grade 11, I'm telling you, you're going to cry in grade 12 if you don't care about what you are doing in grade 11 and you don't make it your priority to master what you are doing in grade 11, because your grade 12 will depend highly. Your grade 12 will depend highly on what you did in grade 11 and highly on what you did in grade 10. So please, guys, you need to know your work. Like, you need to know it so well. So the solutions of a quadratic equation are given by, let's look at this. This is x is equal to negative 2 plus minus the square root, 2p plus 5 over 7. What is this giving you, guys? What vibes are you getting from this? Okay, we're told it's the solutions. So this is the root of the equation, all right? But even with that said, okay, even with that said, what are you seeing underneath the square root? What is this looking like? Isn't this looking like your quadratic formula? Minus b plus minus the square root. Underneath the square root, we should have what underneath the square root? What do we have underneath the square root again, guys? Over 7. So it seems our only concern here is underneath the square root. Underneath the square root. But because underneath the square root, what do we usually have? Okay, remember, even our quadratic formula, we use it to do what? To get the solutions of a quadratic equation. Okay, so under the root, rightfully so, Aiden has said, under the square root is the discriminant. Okay, under the square root is the discriminant. So for this type of question, we need to always know what is underneath the square root. Let's read again. The solutions of a quadratic equation are given by. So this is the form of the quadratic formula. This represents that minus b plus minus. Underneath the square root is our b squared minus 4ac. What is b squared minus 4ac? It is the discriminant. So underneath the square root, we always have the discriminant. Okay, over what? Over 7. Now they are saying state the values of p for which this equation will have two equal solutions. Will have two equal solutions. So first things first, we need to interpret what this means. In light of what? In light of the discriminant. If we say we'll have two equal solutions, I want to ask the first question, what does that mean about delta? Delta is what? To have two equal solutions means what about delta, guys? Two equal solutions. What does that mean about delta? Delta is, I'm waiting for you guys to tell me. Delta is, yes, delta is the discriminant that we know. But if we're saying we'll have two equal solutions, what does that mean about delta? Is delta k? Delta is you're saying delta is positive. Okay, but specifically, the greatest op says delta is equal to 0. It is 0, guys. Look at the wording. Will have two equal solutions. Okay, so that means delta is equal to 0. Delta is equal to 0. Delta is not greater than 0, guys. Delta is equal to 0. Right? Delta is equal to 0. And because I'm saying this, I want to back up a little bit here. Do you still remember this question, guys, where we said x squared minus 6x plus 9 is equal to 0? And we said discuss the nature of roots without solving the equation. Then what we did here is we identified our a, b, and c. We wrote down delta. We substituted into delta. We got the value of delta, and we got delta is equal to what? 0. what did we then conclude? That the roots are real, rational, equal. The roots are real, rational, equal. Right? I want to show you something here. You see this equation? I want us to take it just on its own on the side. And I want us to solve it because I want you to see something. I want you guys to see something very quickly. If we take this equation, x squared minus 6x plus 9 is equal to 0, and we solve it on the side. Let's just say we solve for x. Let's solve it. I open two brackets of x, all right? Then positive means same signs inside the bracket according to the sign of the middle term, which means I'm going to have a negative and a negative. The factors of 9, which if I multiply give me 9, I add give me negative 6, is going to be 3 and 3. Then I have equal to 0 on the other side. Okay? So then, when I write my roots down, I have x minus 3 is equal to 0, x minus 3 is equal to 0. So x is equal to 3 or x is equal to 3. Now, we say x is equal to 3 or x is equal to 3. So we would say these are two will have two equal solutions. These are two equal solutions. Does that make sense, guys? Two equal solutions. But we know that just means x is equal to what? To 3. Okay? This means two equal solutions. All right? I hope you guys understand this. Ultimately, for our graph, we would write the 1x intercept because this means two equal solutions. Okay? So the meaning of two equal solutions is that when you solve that particular equation, you should get two equal solutions, right, that are the same. And therefore, that just means it is just that root. Okay? Okay, so I hope you understand. So when I say here, or the question is asked, the solutions of a quadratic equation are given by that. State the values of p for which this equation will have two equal solutions. What are we going to do? Okay, we are going to grab the expression of delta, which is 2p plus 5. Remember, 2p plus 5 is underneath the square root, and it represents what? Delta. We've already concluded as to what does it mean when we're saying we'll have two equal solutions. We said it means delta is equal to 0. So all we are going to do is we are going to grab the expression underneath the square root, which is 2p plus 5. Isn't 2p plus 5 actually our delta expression? Yes, it is. And then all we do is equate that to 0. That will help us to actually do what? To find the values of p for which this equation will have two equal solutions. We grab delta, the expression underneath the square root. We look at the condition which says the values of p for which this equation will have two equal solutions. Okay. Giovanni, you can ask your question. Please ask your question. You can definitely ask your question. Don't be scared as well to request. You can request, and then we can chat if you want. Okay. So you take your delta, you equate it to 0, and now all we do is we solve. So 2p is equal to negative 5, and then we divide both sides by 2. So p is equal to negative 5 over 2. That's it. Okay, that's it. Because remember, when it comes to nature of roots, the shortcut is to use delta. And in this situation, our shortcut of using delta is accessible. The solutions of a quadratic equation are given by this, right? State the values of P for which this equation will have two equal solutions. What do we have here? From here, we can take the expression underneath the square root. What is the expression underneath the square root? It is delta. What is it equal to? It is equal to 2p plus 5. Then, when they say state the values of P for which this equation will have two equal solutions, what does two equal solution mean where delta is concerned? It means delta is equal to 0. All right. So, if delta is equal to 0, then it means I take my expression of delta, which is 2p plus 5, then equate it to 0. This is 100% fine. Then I solve for P because I've taken the delta expression underneath the square root, equated it to 0. Now I can solve for P by simply transposing 5, becoming -5, dividing both sides by 2, and then getting a P value, which is -5 over 2. Okay. Any questions that you have, you are more than welcome to guest request. You can send me an invite. I can talk through with you whatever it is you need clarity for. But with regards to what we are covering, don't come here and ask me about Riemann's hypothesis, for instance, because currently I am within the confines of helping grade 12 students and grade 11s within the CAPS syllabus. So please guys, Riemann's hypothesis, we can talk about it on the side or some other time, but now, not now, okay? I hope this is clear. Hope this is very clear. Let's go on to question number 2. It says, state the values of P for which this equation, meaning that equation, will have no real solutions. No real solutions. Okay, remember Svalor, the one who's asking about Riemann's hypothesis. You can go and actually engage ChatGPT if you want to, and have a field day discussion there if you'd like to. I definitely would encourage you with that. It would actually really do you good. State the values of P for which this equation will have no real solutions. Do we still remember what it means for delta if we have no real solutions? Still remember what that means for delta? Because we need to clarify what this means for delta. What does it mean, guys? It means delta is, very good, Livia. Discriminant, be very careful. No real. So meaning there's no real solution, meaning non-real solutions. Okay, so be very careful there, born again. Very, very careful. It didn't say real, it said no real solution. Okay, 2024 high, 2024. Okay, it may have well, yeah, because this is a document compiled in 2024, may have well been 2023 as well. No real solutions. Okay, so delta we've established is less than 0 when we say no real solutions. So we grab our expression again, which is 2p plus 5, but this time round, we make it less than 0. There we have it. Delta is less than 0. That's what no real solution means for delta. Very important. Then we grab 2p plus 5. We make it less than 0 this time, so we have a linear inequality from grade 10. We transpose the -5. We divide both sides by 2. We get P is less than -5 over 2. That's what it means to basically find the values for which values of P is a particular equation having a certain condition. All right. Okay. in the Eastern Cape province, underneath the same sort of like question, there was this question. Okay, don't mess around. In the Eastern Cape, I must say, the question papers in the Eastern Cape are quite meaty. Oh, thank you so much, Mrs. Him. You always know when Mrs. Him is here. Ah, man, thank you so much, Mrs. Him, for the you awesomes. I really appreciate them. Thank you, thank you, thank you. Thanks a ton. Right. So we have this question, guys, here. 1.3, given that f of x is equal to x squared plus 3x, 2x minus, then you have this square bracket, tx inside there, all raised to the power half is equal to 0. Then the question says, for which values of k will the equation f of negative x plus t2k over 4 be equal to 0 have equal roots? This, guys, is a meal of a question, and I would really love to actually for a moment just pause here, allow this challenge question to be done. I will give all of you a good 5 minutes. You can have fun with it, and then after 5 minutes I will invite, or I will ask someone to actually come through here and talk us through as to how they did this question. So I want to repeat, this is given f of x is equal to x squared plus 3x. Thank you so much, Mrs. Him. And 2x minus, then you have a square bracket, t of x, then you have the other bracket. I think this is just a bracket to sort of like differentiate between the bracket of x where t of x is concerned and just the entire thing being raised to the power half. That's very important. So that's why they've used different brackets. Equal to 0. Then they're saying, for which values of k will the equation f of negative x plus t of 2k over 4 be equal to 0 have equal roots? Okay, so let me allow you guys to have a crack at it, because of course, as both grade 11 and grade 12 learners who have been taught by your respective teachers and so forth, you should be in the position of being able to answer a question like this. So I'm going to give you a chance to exercise your mind and see how this rolls. So 5 minutes. Currently we 108, so at 113 I will ask that those who feel they want to attempt this will guest request, and they will lead us in how they responded to the question. Okay, let me allow you that time and that space. Enjoy. See this. Bye, Michaela. Functions as well, I'll be going after this, so yeah. functions is where I'm going after this. So yeah, I'm going to functions after this. But unfortunately, it won't be grade 10 functions. It will be grade 11 and grade 12, the combination. Most likely going to end this live around about, say, maybe 2:30. 2:30 might be how far I might be willing to push it. So to those that are having heavy eyes, don't worry, the live will be saved. I will actually be posting it onto my YouTube channel. You can always check it out another time and rewatch the session if you want, so no problem. I just fear if you are saying functions for grade 10, I will obviously not be covering the basics of the grade 10 concepts. It will be grade 11 continuing on. So I just fear that it may just be a bit more than what you bargained. Okay, 2 minutes until we are inviting someone to lead us. All right, let's go. Anyone who's feeling lucky? Anyone who'd like to lead us and direct us, be our director when it comes to this question? The question is pretty nice, simple, and good. It's given f of x is equal to that. 2x minus this here, which is t of x, but it's all raised to the power half, is equal to 0. Now we are being asked here to, what in the world? For which values of k will the equation f of negative x plus t of 2k over 4 be equal to 0 have equal roots? And this is the mark allocation. So usually, what's nice is, or let me say typically in question papers, you'll have your solve for x, very nice, quadratic formula, inequality, surd equation, simultaneous equation, then 1.3, which for some people is a pain, but it always just needs you to be open-minded and to see what needs to be seen. All right. So yes, guys, we are here. Anyone who'd like to come through and do us service? Mimi, T, Livia, Noah, Lucindis, I'm joined, Spinara, born again, Mayenzi, the greatest of. Anyone? So if you guys think about it, you see your equation is there, right? There it is, the equation. All right? The equation is there. But of course, there's these elements, all right? There's these elements, right? So what do you guys want me to do it? You may attempt, yeah? You might attempt, Livia, if you want to. You can come through. All right, it's good to attempt. Mimi's like, at least you're trying, I'm stuck.
Hello. Hello.
Okay, hello, Livia, how are you?
Yo, I don't even know what I'm doing here.
Okay, that's fine. We will discover what you are doing.
No, firstly, I tried to figure out what t of x would be, or t of k, like.
Okay.
So
what did you do?
Well, I am just realizing right now that I may have missed something, because I thought that k was an x. Let me try to redo it. I'm sorry.
Okay. Okay. Okay, anyone else who would like to give this one a cracker? F of x equal to x squared plus 3x, 2x minus, in brackets, tx to the power half is equal to 0, right? Those are given to us. And then they're saying for which values of k will the equation this equal to 0 have equal roots. All right. Yeah. So you can see there's f of negative x but here we have f of x. Here there's t of 2k, but here we have 2x minus t of x raised to the power half equal to 0. Okay, and somehow we need t2 of k. Yeah, sure, you can say what you wrote. Come on through. Come on down. Right? Come on down. You can say what you wrote. Just accept my invite and you can talk so that you can lead me. I want to be led so that I can see how amazing you guys are.
Hello?
Hello.
Oh, yes. Firstly, I started by checking the second equation, which says 2x minus t of x to the power half equal to 0, okay?
Okay.
And then I solve for t of x by firstly taking 2x to the other side.
Okay, I'm listening.
And then I divided the 2x by, yes, you can write.
So you took the 2x to the other side.
Yes,
So it
and
becomes negative.
Negative.
And then you will leave this here. This becomes negative
but we
tx to the power half is equal to negative 2x.
Yes, but we can divide by a negative.
Okay, divide by negative
So
both
as to
sides.
also, and then to remain with the t of x, you can multiply by the inverse of 1 over 2.
Okay, to remain with the t of x, we divide by the inverse of 1 over 2, which is to the power 2.
Yes.
Then I'm left with tx on the left.
And then the right side is going to say 4x squared. Tx is equal to 4x squared.
4x squared.
X squared.
Okay, can I just stop you right
then,
there and just check with the people in the comment section, the audience? Are we feeling what my dear beloved amazing he calls himself, is it what
Lebogang. My name is Lebogang.
Oh, okay. I was trying to read the name there. Okay, all right, hopefully we are all together there. Okay, so I love what you did. You this is like it's pure mathematical skills where someone just says, oh, okay, let's make t of x the subject. How do we make t of x the subject? In grade 10, you guys learned how to make something the subject of an equation. Transpose 2x, it becomes negative 2x on the right hand side. Then after that, he divided both sides because there's a coefficient that's negative divided by negative both sides, so that gives us t of x to the power half. Then to get rid of the exponent, we multiply the exponent that we have by its reciprocal or inverse. You see, so that's 2. Or we could have taken, yeah, it just depends, okay? And then we have the same thing. What we do on the left, we do where? On the right, so that we have t of x is equal to 4x squared. So I love this, bro. I love it too much. Nice. Where to from here?
Then we can continue to the question.
Okay.
Which, yeah, from there.
Okay.
We can just see, yeah, for which values of k will the equation f of negative x plus t into 2k divided by 4 equal to 0 have equal roots?
Okay.
And then you can check that equation.
Yeah. So must I write it down?
Yeah, and yes.
Okay, so f of negative x plus 2 of 2k over 4 is equal to 0. Taken it there.
Yes, and then for f of x, we go to the equation. Let's return to the equation.
Okay. F of x. So what
for
is
f of
that?
x?
F of x.
For f of x is equal to, yes, because they said wherever there's x, there must be negative x. So each and everything we're gonna have negative x squared minus 3x.
Okay. So you are saying because there's f of negative x,
X.
for the
Yes.
function where x is, we substitute negative x. So we are
Yes.
going to do that then. Negative x squared plus 3 negative x.
Yes, and then we can say plus. And then we move where for the equation of t over x, which is equal to 4x squared. And then wherever there's x, we substitute 2k.
Okay, beautiful. So where x is, we are going to substitute 2k.
2k, yes.
So we are going to say 4 into 2k whole thing squared
All squared. Yes.
over 4.
All divide by 4 equal to 0.
Okay. Hey, I'm
Yes,
with
and
you.
then from now on,
I'm with you there. I'm with you there. This is beautiful. I'm hoping for all my audience. So you see what he did here. Just remind me of your name again. You said you are?
Lebogang.
Lebogang. Yeah. Lebogang. Hey, yeah,
Yes.
you are brilliant, my man. You are brilliant. So where f
I'm trying my best.
No, you are doing your best, my friend. You are doing more than trying. You are putting an oomph in the try. You are triumphing. So in the place of f of x, since we have f of negative x, Lebogang says we go to the left-hand side of the expression. We substitute in the place of this x, negative x in the place of x. So that gives us, in the place of f of negative x, we have negative x squared plus 3 into negative x. Beautiful. Then we have the plus that follows. Then we have t of 2k. But we already know that t of x is equal to 4x squared. So in the place of what? Of x, Lebogang has said we substitute k for our expression on the right. There it is. 4 into 2k in brackets. We put the square on the outside over 4 because there's a divided by 4 equal to 0. Hi, we are close. I'm listening. Lead me, Lebogang. I'm glad to be led.
I do have a question from here.
Sure, please.
Let's say I wanna finish real quickly, and then go to the side where it says 4 divided by 4 into 2k all squared divided by 4, and then just cancel out all the 4s same time.
Same time. That's fine.
Is it fine?
Yeah.
Okay, yeah. Okay, let's cancel them out and then we can continue.
Okay. So do you want to cancel them out before you do any of the...
Let's simplify first. Let's simplify first.
Sure.
And then we're gonna have negative x squared minus 3x.
Okay.
Yeah, I think we can now multiply if possible.
Okay. So now we're going to apply the exponent here to what's inside. That gives us what?
Negative x squared. No, positive. Positive x squared.
Yeah. So for those who are viewing, please, guys, whenever you put this negative, guys, very important. Sorry. I forgot now. I canceled the 4, but I forgot to put the brackets there for you. I'm sorry about that. So negative x, thank you, M. Negative x into the square. The square applies both to the sign and to the letter. So the negative sign is affected by the even exponent. It becomes positive. Then if we apply the square to the variable, it becomes x squared. So that's positive x squared. Positive times the negative, we get what, my friend, here?
Negative
3x, and then lastly here
plus 4k squared.
Epic.
And now I think we are done.
Key standard
We are
4.
almost there.
Key
Yes.
standard.
So our delta is gonna be b squared minus 4ac, and yeah, you can write that down.
Delta is equal to b squared minus 4ac, yes.
And then our b is equal to -3. B squared is -3
Yes.
minus 4 into 1.
Yes.
And our c is 4k squared.
Awesome.
And then what's next? Can we simplify?
Yes, let's
The
do
delta.
that. Let's do that.
It's gonna be 9 minus 4 into 16k squared.
Awesome. Negative 16k squared. So that's our value
Yeah.
of delta, the expression in terms of k.
Okay, and then okay.
Yeah, go ahead.
Okay, and then the question says for equal roots, so which means we are going to say delta must be equal to 0, but then our k must have 2 answers, I believe.
Okay. So from there, since the question says for which values of k will the equation have equal roots, we then say delta equal
Yes.
to 0, as you've said. So
Yes.
delta obviously is 9 minus 16k squared equal to 0.
Yeah, and then we solve for k
Awesome.
from here.
So here we solve for k. Okay, let's go.
Negative 16k squared is equal to -9.
Negative 16k squared is equal to 9.
-9.
Negative 9.
And then we divide by -16.
Divide by negative 16.
And we are going to have k squared, which is equal to 9 over 16.
9 over 16.
When we apply the square root to get k by itself,
Okay, apply the
which
square
is going to
root.
be plus. The square root is going to be plus or minus 9 over 16.
9 over 16 plus minus 9 over 16.
Okay, let me use my calculator. 9 over 16. K is going to be plus or minus 3 over 4.
Plus or minus 3 over 4. Okay.
And I believe we are done.
Hell, hi, Baba. Ay. This man. Which province do they cook this kind, my man?
Thank you.
Which province are they cooking this kind?
Which kind? This one?
Yeah, your kind.
I'm from Limpopo.
Hey, Limpopo brothers are doing the most, eh? You guys are killing it there. I can see you are not playing around. You know, maths is like your daily bread.
Hey, not really. Paper
Is it,
two was
bro?
kinda hard for us, but we tried.
My experience, I'm not gonna lie to you. I have a few learners that you know, because I have this platform and I'm doing these live lessons, I have a few learners that are actually, you could say I've become close to them, and I'm getting an opportunity to know them very personally. And like, you know, I've known some of them. We've been on the journey since last year, end of the year, because we kind of started on doing live lessons with some of the learners before schools opened in December last year. So we
Wow.
did the syllabus early, and then term one. By the time term one started, most of the learners that I started with, they were killing it term one, man, like nobody's business. One of the learners, it's just unfortunate that he's not here, but he's also from Limpopo. Term one, he got 99%. Term two is killing 99%. He's very angry because he's like, I keep on missing the 100.
Oh, I actually dropped in term two also, because in term one I got 99, and then
Yeah.
in term two, yo, I dropped to 95. Yeah,
Yeah,
I
that's a
almost
key.
died.
Is it? Eh? Yeah, I know you guys. That's why I'm saying I have so much respect. That particular learner is in grade 11, and then I have another one who's in grade 10 that I've also gotten to know quite personally because, like I said, it's been the journey since last year with them, and so we've become very close as a result. And same thing, like I think she dropped term two, but term one, she was just like killing it and she dropped term two. But what I love is the drop is always within the 90% range, which is always great. I mean, it's just only a matter of time. You twig what you need to twig, you learn what you learn, and then you take it through. So, I have mega respect for Limpopo and say I'm from a faraway province from you guys, but hey, I have respect. No, totally.
Which province are you from?
I'm from the Eastern Cape, buddy. Eastern Cape.
Oh, okay.
Yeah,
Get it.
yeah. But mega respect for my Limpopo brothers and sisters there. No, I've come to learn to respect the mathematics that flows. You know, it seems like they do a solid job with the basics and everything. So it's good. It's very inspiring.
Yeah, we actually have like a dedicated teacher like yourself actually in our school, because he started monitored us in grade 9, I think. Yeah,
Yes.
and then he started teaching us grade 10 stuff at like probably December, and then we moved on to January, and then we actually moved from there.
Yeah.
Ever since, we don't really depend that much on him,
Yeah, that's how we did.
because mostly we usually teach each other most of the time. Even if he's absent, yeah, we usually
Yep.
take over, and
I,
then
you see,
do the business.
you are my kind of student because that's exactly. You see, me, I have my own class as well. Like, in the particular school I teach, but my learners are very self-sufficient. Even with these live lessons, I'm sure some of them they'll join, but most of them they're so sick and tired anyways of me and they like, I say we'll do our things. We'll consult you if there's anything will consult you. So they treat me as a consultant. They are the main characters, and I love that, man, because at the end of the day, that self-sufficiency and that independence is very key for when a learner goes into tertiary level education. So to cultivate that now is such an important thing. So I must keep it up, buddy. And props to your
Thank you,
teacher.
sir.
I props to your teacher. I think teachers that are like that, I have mega respect for, like nobody's business. Because I know what it means to help your learners in grade 8 and 9 and to sort of like get that work ethic and also to put them at an advantage, like put them at an advantage where they know a lot of things even earlier on so that they become self-confident and the maths just flows. You see, so I respect to that teacher, Baba. If that teacher was here, I would definitely
Yeah,
just
I
give
know.
him his flowers. He's the man.
It's actually a she.
It's a she. Yo,
We are
man.
taught by a
Even
she,
better.
actually.
Yo.
Yes, and she's young. That's why we understand her mostly,
Yeah.
because she knows how we work.
Yeah.
She's like way young.
I see.
So yeah, we
No, no,
understand
no.
each other most of the time.
That's power. That's power. No,
But yeah, let me not disturb. Continue.
no, thank you so much, and thanks for joining in and actually smoothly answering this question. Because yeah, it's really, really good the way you did it. Thank you so much.
And no worries.
Sure. All right, guys, that was a very good, beautiful attempt. And this question, right, is actually really not so different from type 2 because you see, under type 2 questions, there is the questions where you are given your roots, like we had done in that first question, and then they just ask you for which values of that particular variable So your discriminant is always found underneath the square root, and it's a matter of you interpreting whatever they have asked, whatever condition. So if they say equal roots, obviously that means delta is equal to 0. You just take your discriminant, you equate to 0. Non-real, it means you take your discriminant, you make it less than 0. But in other cases and situations, just like this question, okay, it's very rare, I think for this question, obviously they wanted to just up the level of the type of question, make it a bit complex by adding spice like f of x and t of x in the mix. The fundamental thing is the equation that you need to actually get, right? The equation that you need to get. That equation, once you have it, you need to get it into standard form, which is fundamentally what we wanted to get to. All of this was just red tape. All of this was red tape. Where we wanted to get was the equation in standard form. We have the variable x, but we also have the k variable, which is the one that they are asking us to find the value of k, by which this equation will have what? Equal roots. So the condition in this case is equal roots. So what we then do is we take that particular equation that we have in standard form, we use delta, identify a, the b, and the c, get our delta expression in terms of k. This delta expression should always lead us to an expression where that variable that they were asking us to solve will actually be there. You can see there's no x here. There's only k and constants. So then when you get to the delta expression, you can then come back to the statement and read it. It says for which values of k will which equation? This equation that you got have what? Have equal roots. So once you have the expression in terms of k, the only other question you ask yourself is, what does this condition mean for delta? Guys, do you remember that in this question, we were asking, what does this condition mean for delta? Two equal solutions. We know that that means delta is equal to 0. No real solutions. We know that delta is less than 0. So we are asking the same question here. What does this condition mean for delta? Equal roots. It simply means that delta is equal to 0. That's what it means. Okay. Then from there, we take our expression of delta, we equate it to 0, and we solve for k. And you see what we have here? We have a quadratic equation when we need to solve for k. So we solve that quadratic equation, and I mean, my friend here, simply what he did here was transpose the constant term and solve for k. Someone else would have probably used difference of two squares, open two brackets, and solve for k. You would still gotten two solutions, and that is k is equal to positive 3 over 4, or k is equal to negative 3 over 4. Now, I think Olivia had a question. I have one question. So what is that question, Olivia? Let's give you a chance to ask that question that you have. What's the question, Olivia? Do I need you on here, or will you just comfortably ask the question from there? You have said you have one question. One question only.
Yes, sir.
Olivia, you said you have a question.
From the b squared minus 4ac.
So from here.
Right. Just below that. Like, I'm trying to figure out how you multiplied that, because when I was doing it, I got like negative 3 squared,
which is 9.
And then I multiplied the negative 4 with 1, and then I multiplied the negative 4 with the 4k squared. So did I make a mistake there, or?
Yes, you did. Okay, you did the typical mistake that most learners make, and that is think that this is separate terms. So negative 4 and 1 and 4k squared are one term, right? So we are simply multiplying negative 4 times 1, we get negative 4. Then negative 4 times 4k gives us negative 16k squared. Make sense?
Yeah, it
You are
does.
multiplying these and these and these. You are not saying negative 4 times 1, negative 4. Negative 4 times 4k squared, negative 16. That's where the dynamics or the problem will start, and then you'll have maybe an answer that's not supposed to be. This is one term because multiplication combines terms together. So this is one thing. You just multiply negative 4 times 1, negative 4. Negative 4 times 4k squared, negative 16k squared.
Understood. I will never make that mistake again.
Amen. Hallelujah. Hallelujah. And more hallelujahs to you. I'm sure you'll never make that mistake again because it will cost you. It will make you actually be in that situation that my good friend was crying there of 99%. I didn't ask him what it is that made him fall short of the 99%, of the 100% that he probably was gunning for.
Okay, thank you, sir.
You are welcome. Thank you so much for asking the question and getting your clarification. Okay. All right. So that was a jam-packed question for nature of foods. All right. Now I'd like to turn my attention, guys. Like I said, I'm going to end the live at 3 o'clock. So if you're feeling tired, you're feeling woozy, and you want to sleep, please go. I don't want you to pass out on the live. It will be very painful if you do. Okay, I'm going to turn my attention now to functions. Functions are very nice, right? People enjoy functions, don't they? Can you guys tell me? So I think at the top you're already told. So this is the Eastern Cape question on functions, and we are told here to consider the function. Guys, hyperbola functions need to be like one of those functions where you just chow everything. Do you guys know how to chow maths and just chow everything when it's there to be chowed? It's very important to know how to properly chow maths and make sure that you leave no mark or stone of marks unturned. Okay, so first and foremost, are we all familiar with hyperbola functions? Can I confidently move on without really explaining what's happening with this function? Do we all understand what a hyperbola function is? If not, I would be happy to unpack for you the basics and the fundamentals that have to do with this function. But if you guys are comfortable and you say, so there's no real need for that, then you know what, we can go straight into the questions. And I'll be happy to actually see as we answer those questions. Can you guys hold on a bit here? I will explain. Just hang on. All right, guys, it seems like I'm going to have to explain just very briefly so that we are all in the same page. So I'll do that. And that is for who's this person that said, please explain. Let's just check. T. Okay. Very quickly, the concept of a hyperbola function. Y is equal to a over x plus p plus q. Okay. So our a value, all right, is a very important value because when a is greater than 0, a hyperbola function has what we call two asymptotes. Now, what in the world is an asymptote? An asymptote is simply a boundary line where the hyperbola function does not touch. Okay, so it's a boundary line where the hyperbola function doesn't touch. Okay, I usually say to learners that even as an individual, you need to have asymptotes. You have to have boundaries. Okay, places, things that never touch you, that you never do. Why? Because, yeah, as an individual, you need to have those boundaries. If you don't have boundaries, then everything will be acceptable to you. Everything you will do, and sometimes you'll do things or things will be done to you that are destructive. So you need to have boundaries. So in order for hyperbola to exist, these boundaries have to be there. If they don't, the hyperbola loses its identity. So we have a horizontal asymptote given by y is equal to, now it's y is equal to this q value. Okay. Then we have a vertical asymptote, which is given by x is equal to the inverse of p. And I'm very specific in saying the inverse because it is always the additive inverse of whatever the p value is. So since I have x plus p, I would typically say here this is x is equal to negative p because it's always the additive inverse of the p value. That's my equation of the vertical asymptote. We call this the vertical. Vertical means from top to bottom. Horizontal means from left to right. So there's a horizontal asymptote given by the q value. So when we write it, we say y is equal to whatever the value of q is. Then the vertical asymptote, when we write the equation, we say x is equal to whatever the inverse of p is. All right. I hope that makes sense. T, you need to say to me, I'm making sense to you in the comment section. You are the one. Actually, let's do this. T is the one that said I must explain. T must be here. T, you must come on here so that when I'm explaining something, you must be here to say, I understand, say, I can move on. Because I need to move on quite briefly and briskly through this so that we can go and attempt and answer the questions. So T, why is T not accepting my invite? Okay, T is finally accepting my invite. T, you are the one that needs to say to me, yay, nay, I don't understand. Explain that. T, are we together so far?
Hello?
Hello, T. Hello, T. The name is T, according to what I
No,
see.
sir. My name is Nombulelo. I can't change the T on TikTok.
You can't change the T on TikTok. That's funny.
Yes.
Oh, okay. Yeah. You see when you give your name the name T and it's TikTok, then you can't change the T. All right. So Nombulelo, you need to confirm for me that you've heard me. That y is equal to a over x plus p plus q is the standard form function for a hyperbola function. Do you understand that, firstly?
Yes, sir.
Okay. Then we have x plus p in the denominator, and then we have plus q there. So for a hyperbola function to exist, there needs to be these things that we call asymptotes. We have two of them. Are we together there that there are two asymptotes?
Yes, sir.
A vertical asymptote and a horizontal one. The vertical asymptote, I said, will be given by the equation x is equal to, we always look at the expression in the denominator, x plus p, but then the value of the asymptote, the vertical asymptote, is going to be x is equal to the inverse of whatever this p value is. So since there is p here, I can say x is equal to negative p, but this is generally speaking. X is equal to negative p. Okay? That's your vertical asymptote. Yes? No?
I understand, sir.
Okay, and then your horizontal asymptote is given by the equation y is equal to q, this q value. Y is equal to q. All right, so whatever the value is what we would substitute here. So the q value as it is, that's your horizontal asymptote, but the x value, the inverse, is the equation of the vertical asymptote. Then when a here tells us about the shape and the position of the hyperbola in relation to the asymptote. Okay, so if a is greater than 0, we expect to find our function in the in the first and the third quadrant. Like that. If a is greater than 0, first and third quadrant. That's where your sketch will be. That's where it will be found. It won't cross this line, it won't cross that line, but it will come close to this line and it will approach that line but never touch it. And we call this a decreasing function. It decreases, it decreases, it decreases everywhere. All right. What about when a is less than 0? Can you tell me which quadrants will I find my function if a is less than 0? Shape and position.
The second and fourth quadrant.
Amen. Okay. So there was I'm guessing there's probably no need for me to explain this then. It seems like you're quite sorted if I hear you very well.
Yeah, I'm not. I like the basics. I'm not.
Okay. All right. Don't worry. We are just going to continue then. If you are reassuring me that you are not, then that gives me reason to continue. So that means this is an increasing function. Do you see the shape of the function? I hope you see the shape. This is not a straight line, but it is a curve. It is a smooth curve. It's very smooth. It's very smooth. Smooth curve. All right. It approaches that boundary line, but never touches it. Approaches that boundary line, never touches. It's like it's playing with fire. This function plays with fire, but it never touches. Okay. And that is not an invitation for other people to play with fire. We don't play with fire, people. Yeah? Don't play with fire. So that is very important then with understanding the function. Our a value, when it's less than 0, that's the expectation of the quadrants. It's increasing because as x increases, y increases. As x increases, you can see y is doing what? It's also increasing. So this is an increasing function everywhere. Right. All right. I think that helps a lot as far as understanding A, P, and Q. But furthermore, we understand that Q, our Q value, all right, tells us something else. Whenever Q is positive, or at least when we increase the value of Q, we add something to Q. We know that speaks to the vertical shift. But in what direction? Up or down? If Q is greater than 0. What do you think, Q? What do you think?
Greater than 0.
Yeah. Amen. When Q is less than 0, vertical shift in what direction? What do you think? Bulan?
Up. Oh, less than, it shifts downwards.
Amen. Okay. That's why I'm saying to you, I think when you understand even the basics most. Okay. So here we know that Q has to do with vertical shift. P, on the other hand, has to do with horizontal. Horizontal what? Shift. But there's this word here that I want to actually write, and that is the word counterintuitive. I'm sorry for my writing. Writing is, I think I was actually meant to be a doctor in my lifetime, but I fought it, this thing. Okay, horizontal shift. So when P is greater than 0, okay, that's great. Thank you, Livia. That's actually really encouraging. Girls tend to have the most amazing writing, so I don't know even if how that's even possible. P is greater than 0. What does it mean when P is greater than 0? We know that speaks to horizontal shift, but in what direction? Left or right? What do you think, my dear friend Nombulelo? What do you think? When P is greater than 0? Left or right? What do you think? Let's see. What's your best guess? Or what do you know?
I don't know, but because you said counter that word, then I think it's the opposite of what I would think. So greater is left.
Yeah. I jonga.
Then right.
When you know what you know. I think you just wanted me to bring you up here, didn't you?
No, sir, I don't.
No, you did.
No, I don't, sir.
Okay, no, I'm just kidding. Okay, so yes, definitely. I love the fact that without even me explaining, I have oftentimes have to explain what this word means to my learners, but you literally just said because of the word that you wrote down, which means you have a pretty good comprehension of English words and their meaning, you were able to unpack what this means without me asking you. And then when I asked you this question, you decided, no, I'm going to tell Sir that P greater than 0, it's not what I think. It's actually it's against what I think. It's left here, it's right here. And you are 100% correct. 100. Like you have explained it so well. I am so chuffed. Did you hear that deafening round of applause on your behalf?
I did. Thank you, sir.
Yeah, thank you so much as well for just explaining that and making life easy for me. All right. Next part, which I think is very important, is the issue of domain and range. Nombulelo, what is the domain of a function? What do you understand is the definition of domain?
Okay. Domain has to do with the x values, and then range has to do with the y values. But I don't know where to from there.
All right. Then what I want to then ask from you is, no, that's great. You are right. Domain does have to do with the x values. It's the x values where the function exists. And if you are talking about the x values, all right, what is your direction? This is from left to right, because your x-axis is from left to right. Are you with me?
Yes, sir.
Then range is your y values where the function exists. Where does the function exist? And since y values are from the bottom to the top, then it's from the bottom to the top. Okay? Left to right, because small values of x are on the left, big values are on the right. Y values from the bottom to the top, where the function exists. Why do we say from the bottom to top? It's because small values of y are at the bottom, big values of y are at the top. Make sense?
Yes, sir.
Now I want to ask you a question, Nombulelo. This is my hyperbola. Thank you so much, Kay, for the Rosa. Hey, Rosa, really appreciate. This is a hyperbola. From left to right, does the function exist everywhere, Nombulelo?
No, sir.
Where does it not exist?
In the middle, where we have the asymptote.
Amen, Nombulelo. Nombulelo, man, when you are just... So, Nombulelo, if that is the case, what is the domain of the function, generally speaking, for a hyperbola? How would we write it?
I think the x is in the middle. I don't know what it's called, sir, but the one with the x in the middle.
The one with the x in the middle.
Is it that one? Or is it two separate ones?
So, I'm asking again. If now you are going to write where the function exists, where does the function exist for the hyperbola? From left to right. If you were to then explain to me, where does it exist? Where does it exist? Does it exist on this side of the line in the middle? Does it exist on this side? Does it exist everywhere on this side?
I think so.
It does, right? Because here's the hyperbola here. Okay. So it exists everywhere on this side. Does it exist everywhere on this side?
Yes, sir.
Of the line? Yes, it does, because here it is. And this arrow indicates that it will go on infinitely on this direction. And that arrow indicates that it will go on infinitely in that direction. So what I'm asking, from left to right, where does the function exist? Does it exist on the line here in the middle? You said no, right? Doesn't exist here. But it exists here, and it exists everywhere there. So how would you write the domain then? What would you say is the domain of the function? So to write the domain, we say x is an element of real numbers. Okay? This here is telling us that the function exists everywhere. I usually tell my learners that this ER, this is not like the letter E, but it's like a symbol that indicates for all real numbers from left to right, the function exists. There's only one condition. X cannot be the what? The vertical asymptote. In other words, it cannot be the value of the vertical asymptote. Okay. So I need to check with you now, Nombulelo. Do you understand what I am saying by saying the domain is this?
Yes, sir.
So x is an element of real numbers. What do I mean by that? I mean the function exists everywhere. From left to right, the function exists. All right. Someone else would say x is an element of negative infinity to positive infinity. This is the same thing as x is an element of R. You open the brackets, negative infinity to positive infinity. But then I write this symbol, which is a semicolon, to mean but. But x cannot be. This symbol means cannot be. It cannot be what? It cannot be the value of the vertical asymptote, because the function does not exist there on this vertical line. Okay. So together, so far, Nombule.
Yes, sir.
Range. What about the range? So we are going to look at the same function from the bottom to the top. Does the function exist everywhere on this function? I mean, on this, like from the bottom to the top, does the function exist everywhere? CMOS, the function here, it is, from the bottom, it's existing. Then where does it not exist? It does not exist where? On this horizontal line. Does that make sense? Does not exist on this horizontal line. But then it continues to exist after that line everywhere, all the way. So what would you say then is the range of this function?
Y.
Yes.
R.
Thank you. Y is an element of R.
And then semicolon.
Yes.
Y is not equal to Q.
Thank you. Thank you so much. You are spot on, dead spot on. Okay. So like I said, guys, this is not the letter E, but it is like a symbol that means element. Okay. Because that just means that the function exists for every real number on the y-axis from the bottom to the top. But the condition is it cannot exist on the horizontal asymptote, which is it cannot be existing where the q value is that value there of the asymptote. Okay, that's domain and range. Okay, you have just successfully shown us how to write the domain and range. But you are going to be specific. All right, remember, you're not going to write q and p. You are going to write whatever the value is here and there when you actually answer the specific questions that you are given. Make sense?
Yes, sir.
I want to speak about one last thing before then, and that is this issue. Ndwana, the reason why we use q is because for your hyperbola, it is always the value of q that is the value of the horizontal asymptote. Q as it is. Q as it is, as it appears. Okay, Q as it appears. All right, let me just give you a chance, Star Christy. Yeah. Let me just remove the comment section so that you guys can... Star Christy, I think you've been asking me to screenshot for the longest time, but I've just been ignoring you. I'm sorry about that. So that's the first part. Okay, I don't know, like, it's just that sometimes when I write, like I said, it's not write worthy. I don't know how people do it, but there it is. Hopefully you've screenshot there. I'm gonna move down. Then this is the second part of it, the second half of what I've just gone through now. Okay, I'm hoping we have screenshotted those two sufficient and I can actually now move my camera. Okay, so just to answer that question by that young man, I said q, we take the value of q as it is. Okay, please take note of that. We take the value of q as it is. Then that's why we say the horizontal asymptote is y is equal to that q value. But as for the vertical asymptote, it's the inverse of the p-value. Right, and that's very important. It's the inverse of the p-value, because here we are concerned about what is the value of p. I mean, what's the value of x that we will substitute that will make the denominator 0? That's our concern here. So that's why we work on the inverse, being the vertical asymptote. Okay. Yeah. So we say x plus p, we equate it to 0, then we solve for that p value, and it's the inverse. So it's the inverse for the vertical asymptote, but it is q as it is for the horizontal asymptote. The last thing I want to talk about is what we call the axis of, or the axes of symmetry. Okay, there are other things that we can obviously get into when it comes to the hyperbola, the sketching of the hyperbola 1, and then 2, finding the equation. All right, we'll get into that when we answer the questions so that you can see it practically, how it comes about. So I hope you can actually be okay with me explaining hyperbola up until this point. Then we'll do practical examples so that you can see how we go about, with other things. I hope it's fine with that, Nombule. Hope you're good with that.
It is, sir.
Okay, so your axis of symmetry, you have how many axes of symmetry when it comes to a hyperbola? You have 2 of them. Okay, and me, I just say to learners, there's a template for this, man, and I think the template is sufficient. Okay, there are 2 axes of symmetry. There's one equation of the axis of symmetry which will have a gradient that is positive 1. That's the positive gradient axis of symmetry. So the positive grad axis of symmetry will have a gradient that is 1, and then you have a negative gradient axis of symmetry which will be negative 1. And that's it. The gradients for each axis of symmetry, the one that is positive will be positive 1, the one that is negative will be negative 1. So what you do, you have a template here. The gradient for the positive one, you will write the gradient outside this bracket. In the bracket, all you write is you take what you have here in the denominator, you put it in there. What's in the denominator? You put in there. So whatever it is, what's the value of q, you go and put it right there. And then all you do is you distribute the 1 into this bracket, then you add like terms. That's the equation. Done. Finished. Positive gradient of x of symmetry, finished. For your negative gradient x of symmetry, same template. In the first bracket, you put what's in this denominator. Then outside of it, you write whatever q, the value of q is. Then what you do, you distribute, you add like terms, equation, finished. So that's how you get your equations of the axis of symmetry. There's nothing else that you need to complicate about getting the equations of the axis of symmetry. Right. So, Nombulelo for now. I hope that we have at least given you some sort of like green light to say, well, there's something that you do know. We're very proud of you that you know those things. I think probably what you wanted me to do right now was just remind you. I don't think it was a matter of like, please do it. I don't know at all. You definitely know a lot. Yeah, well, and more than anything else, you've got a very sharp mind. You've got great comprehension skills. You understand the English language very well. That even interpretation questions, you would have no problem navigating through interpretation questions, given that your comprehension of English and is so good. Remember? Great positives there.
Thank you, sir.
No,
I
thank you.
understand now.
Thank you. I appreciate you allowing yourself to actually come on. I do realize that the dogs were barking and you probably didn't want, but I appreciate it. Thanks.
Okay, thank you, sir.
All right, cheers. Okay, so let us come here then, guys, and look at these questions, and hopefully get an opportunity to now apply what we've learned. Consider the function f of x is equal to negative 1 over x plus 5 minus 2. F of x is equal to negative 1 over x plus 5 minus 2. You see me, the way that I think, I look at this and I'm like, already in my head, I'm like, if ever we were to be asked to sketch this function, I can already see in which quadrants the function will exist. Okay? And because I know how to find asymptotes, I also have a good idea what the equations of the asymptotes will be. I can see so many things already. Ziana will. I'll be uploading this there. All right. So let's go ahead. The first question says, write down the equations. This is plural, guys. It didn't say equation. It says equations of asymptotes of f. So in the comment section, I want you to tell me first, let's start with the horizontal asymptote. What is the equation of the horizontal asymptote? Please answer the question I'm asking. Don't answer all the questions. Answer just this. I want you to answer the one I'm asking verbally. What is the equation of the horizontal asymptote? Comment section. Equation of the horizontal asymptote. Equation of the horizontal asymptote. Okay, Livia seems to be the only one that's actually alive at this point in time. I think we have a lot of, what is it called, dead bodies. Masaseka, the equation of the horizontal asymptote. Remember, I said horizontal. So where are you looking when I say horizontal asymptote? Okay. Guys, I see your answers, and a part of me is hurt by the answers that you are giving. The equation of the horizontal asymptote. YouTube channel is in the link, my dear friend Star Christie. The link, sorry, of the YouTube channel is in my bio. That's what I think I say a lot of things that I don't know what I mean because I'm tired, I think. The link of the YouTube channel is in my bio. It's also called Maths is a Game. You can find it there. And these videos specifically, you'll find them under the heading banner, grade 12 prep for trial exams 2025. There's a playlist that I've actually compiled where I just throw all these videos that I'm doing here. So guys, the equation of the horizontal asymptote. Okay. Where are we looking? We are looking I'm sleepy. Okay. We are looking at negative 2 here, guys. That's what we are looking at when we are looking at horizontal asymptote. We are looking at this negative 2. All right. That's what we are looking at. But when we write the equation, let's not make the mistake. We must write y is equal to negative 2 to get all the marks. Okay. So you can say horizontal HA, but please, guys, after writing this, please write the equation y is equal to negative 2. You can't say HA is equal to negative 2. No, that's wrong. You write y is equal to negative 2. This is our horizontal asymptote. Next question, what is our vertical asymptote? Because they said write down the equations of the asymptote. So our horizontal asymptote is y is equal to negative 2. What is the equation of the vertical asymptote? What is the equation of the vertical asymptote? The equation of the vertical asymptote. Oh, it keeps on telling you about settings. Ish. Okay. I'm sorry about that, guys. Okay. I think I'm going to have to take care of my settings. Okay, it's fine. It's fine. If you guys write the number, then I'll understand. Okay. So the equation there is x is equal to, remember, the inverse, guys. The inverse. So you guys have done it correctly. X is equal to -5. I see Tebucho there has found a way to actually like space it out so that he gets the answer. Tebucho, round of applause to you. X, the first comment, equal the second comment, -5, the third comment. Wonderful. Okay, there we have it, guys. The equation of the asymptotes. We have them. Y is equal to -2, x is equal to -5. Let's move on to the next question. Determine the coordinates of the x-intercept of f. Let me allow you guys to do that. Determine the coordinates of the x-intercept. What do we mean when we say x-intercept? What should we do? Because we want the coordinates of the x-intercept of f. They want us to give the coordinates. They don't want us to give the x-intercept. They want the coordinates of the x-intercept of f. Yes, you can ask Star Christy. You are more than welcome to ask. Guys, please, if you want to, you can always request. If, let's say, for instance, you want to verbalize your question or anything of that nature, please, you can go ahead and send your request or you do what you need to do. I don't mind. Why is it -5? Star Christy, you joined the live. You missed out on that point. Okay, remember, what did we say? We said that our vertical, and I guess you see now there was wisdom in explaining this to Nombulelo, because those who were listening would have grasped that I said that when we write the equation of the vertical asymptote, we are writing the equation, but what we do is we understand that we take the x plus 5, we equate it to 0. Then we solve for x, we get x is equal to -5. All right, because what we are mindful of in this fraction, what is the value of x that would make this denominator 0? What would make this fraction undefined? That's if x is equal to a value that if we add to 5 will give us 0. What is that value? It's x is equal to -5. That's why we call this the what? The vertical asymptote, because it is the value of x where the function is not defined. The asymptote is basically the place where the function is not defined. Okay, so that's why we don't say x is equal to 5. We say x is equal to the inverse of the constant term in the denominator. So we say x is equal to -5. All right. So I hope that's clear for you, Christy. Okay. You're welcome. Now, we want to determine the coordinates of the x-intercept of f. So hopefully, as Livia, I think Livia actually spelled it out there in the comment section and said, we let y be equal to 0 when we want the x-intercept. Okay, then we solve afterwards. Bindwana is saying there, and the easy is saying after we let y be equal to 0, we then solve for x. Mlondi Dumakude says we get the answer 9/4 and 0. Do we all agree? Is it 9/4 and 0? Mlondi Dumakude says that is the answer we get for our x coordinate. For our coordinates. Now, Ntwana disagrees, says no. So I'm waiting then for people to comment with the correct answer. Mlondi Dumakude changes the answer and says 9/2. Is that one the one that's the chosen answer? It is the chosen answer, the chosen one. Mlondi Dumakude changes the answer and says -9/2. Mlondi is like playing around there, like changing answers, like I don't know, it's like changing underwear. Ndwana negative 11 over 2. Spinara negative 11, Temucho negative 11 over 2. It seems like there is a common answer of negative 11 over 2. So guys, very quickly, we let y be equal to 0. Just want to confirm these answers that we got there. We write in the place of f of x, because y is f of x, we write 0 is equal to negative 1 over x plus 5 minus 2. Easy way out here, transpose the negative 2, becomes positive 2 on the left-hand side, then we cross multiply. In other words, we use the LCD and we multiply left and right by the LCD. It cancels there, and then we have 2 into x plus 5. So it's 2x plus 10 is equal to negative 1. We transpose the 10, negative 1 minus 10. So we have 2x is equal to negative 11. We divide both sides by 2. We get x is equal to negative 11 over 2. So yes, those people that said x is equal to negative 11 over 2, we write the coordinates, because remember they did say determine the coordinates of the x-intercept of f. If they ask for coordinates, guys, we give them what they want. What did we let be equal to 0? We let y. Then that allows us to solve for x, and we get negative 11 over 2. So you guys that said said negative 11 over 2, you did a very good job. Okay. Oh, you're writing. Okay. Let me just give you a chance there. Let's zoom out a bit there. Please let me know if you guys think I should remove the comment section for the purpose of those who might want to have clarity in the writing. So what I did there, like I said, I let y be equal to 0. Then after that, I take the negative 2, I transpose it to the left-hand side. Negative 2 gets transposed, it becomes positive 2 on the left-hand side. Then after that, I have a denominator, which is x plus 5. That is my LCD. And what do I do with my LCD? I find the restriction. I know x cannot be negative 5. Then I take the LCD and I multiply by it, left and right. When I do that, the x plus 5 in the numerator cancels this x plus 5. I'm left with negative 1. The same x plus 5 I multiply on the left, I get 2 into x plus 5. When I distribute, what's 2 times x? Get 2x. 2 times 5, I get 10. So I have 2x plus 10 is equal to what? Negative 1. Then I transpose the 10. I get negative 10 on the right-hand side. What's minus 1 minus 10? Negative 11. Then after that, I divide both sides by who? By 2, which gives me x is equal to who? Negative 11 over 2. Then I can write my coordinates. Remember, this is x, belongs in the x place of the point, and then this the y. You remember, I let y be 0, so it's understandable that that y that I let be 0 needs to be the 0 that appears as my y coordinate in my point. Okay, it makes sense, guys. I hope it makes sense. Very clear, Amos. Phoenix C 7. Please do grade 11 general solution next time, please. If you can send me a big gift, Phoenix, I will have no problem. I have no problem with doing that for you next time. I can see you are a level 1 gifter there. Okay. Yeah, remember guys, these special requests that you have, I did say last time in the live that I'm no longer doing special requests until someone does something that will motivate me to do such, and then I'll do it for you in the future. You will be priority, priority. But for now, I'm doing what I want to do because I dictate the terms and what I do because I govern myself. Make sense? I hope that makes sense, guys. And I mean, it's only fair. It's only fair, Yeah. After all, this is free bees. This is free bees, guys. This is free bees. Bees that are free. Bees that are free. What do you expect from free bees? Okay. But remember, this is quality freebies. I don't know where else. Quality freebies. Are you telling me 2:35 a.m. your teacher is waking up teaching you maths? Aye, come on, guys, come on. 4.3. Determine the coordinates of the y-intercept of f. Now, what do we mean now by y-intercept of f? Y-intercept. Y-intercept. What do I know when they say y-intercept? Livia, let x be 0. Do we all understand that? That when we say y-intercept, we let x be equal to 0. When we say x-intercept, we let y be equal to 0. Let's be very deliberate in that. Primrose, I can see you also get it. So when we determine the coordinates of the y-intercept, then we need to let what? X be equal to 0. Go ahead, guys, find the coordinates and then populate the answers for me in the comment section, and then I will confirm the truth that you have declared by doing it after I've seen that in the comment section you are getting your ducks in a row. Determine or determine the coordinates of the y-intercept of f. Yeah. Oh, Spinara. Spinapine moyeni. Spinara is spinnering us, guys. I think Spinara is the real Uncle Waffles, if you ask me. Negative 11 over 5. Primrose negative 11. Tebucho negative 11 over 5. We are negative 11 over 5 ingot there, it seems. Star Christie as well is Christing it up. You. Spinara is the calculator of the group. Wow. You've heard it. Spinara, you are spinnering us, my leader. Kylo got negative 10 over 7. Oh, look at Cliff, my bossing. The bozzer man. Ask Casper in your vest. Oh my goodness, are you kidding me? This guy. All right. Determine the coordinates of the y-intercept. Let's check. We let x be equal to 0. I want to check these answers, especially that negative 10 over 7. That Gayello. I think Gayello must be doing something. F0. Okay. Remember, we have f of x. So we let x be equal to 0, which means we say f0, which means everywhere where x is, we are going to substitute who? 0. Let's go. Negative 1 over 0 plus 5 minus 2. We have negative 1 over 5 minus 2. From this point, people just grab their calculator, you put the answer, and you get the answer. You should get, guys, negative 11 over 5. Aye Kokisi, guys. Aye Kokisi. It's not boorable. It's just that. Then, therefore, our coordinates, be careful. You let x be 0. You write 0. You begin with him. You end with negative 11 over 5. Don't make the mistake of writing your coordinates incorrectly, because if it happens, you write negative 11 over 5 first, you follow it with 0. That's where the downfall, that is where the danger is. That is where the danger is. All right, 4.3. Okay. Feeling lucky? Feeling good so far? I can see even my star Christie there is being a star, like moving so smoothly, like a pro. 4.4. Sketch the graph of f, show clearly all, and Primrose as well. Sketch the graph of f, show clearly all asymptotes and intercepts with the axes. Sketch the graph of f. You see, if Nombulelo is here, this is the part where I would say, now to sketch the function, this is how we go about sketching the function. Okay. So to sketch the graph of f, show clearly all asymptotes and intercepts with the axes. Me pretending like I understand. Zintle Zinkari, did you just join the line or have you been here? And if it is that you've been here, why have you been quiet if you are pretending like you understand? What is the purpose of being in this live if you will still do the very same thing you've been doing in class? Pretend that you know and you understand, but you don't. Isn't that just waking up and being up for nothing if you're not going to ask? Guys, that's the whole purpose. I know there's a lot of people here that are on the live, but some of you choose to not bring yourself forward and ask questions. Okay. Yeah, please, you need to ask the question if you know, if you are lost somewhere. Because if you are not if you're not asking the question, then it becomes a problem. Then you're just continuing to make things even more and more difficult for yourself, not for anyone else. So 4.4 says sketch the graph of f. I upload the live session after I'm done. Kratos Chronicles. I upload it onto my YouTube channel. You can find the link in my bio. It's there. So you can go and rewatch the session, when I do upload it. Sketch the graph of f, show clearly all asymptotes and intercepts with the axes. So let's do this. Let's sketch. Let's see. We already have some information. For instance, we found the x-intercept, which is great. Our x-intercept is negative 11 over 2 and 0. We have our y-intercept. It's 0 and negative 11 over 5. Right. Now, these two are important. Followed by that is our a. Our a value. Okay, remember the form of the hyperbola function is a over. The a value is negative 1. So a is equal to negative 1. That means a is less than 0. In my head already, in rough, I'm expecting to have my hyperbola arms in the what? In the second and the fourth quadrant. Why? Because a is less than 0. This is something that we established, me together with Nombulelo earlier on. Okay, earlier on, me and Nombulelo, we established this, that when a is equal to a negative value, a is less than 0, then we know that our function is found in the second and the fourth quadrant. So I begin with the sketch with the end in mind. Then for my horizontal asymptote and my vertical asymptote, I have those, don't I? My horizontal asymptote was y is equal to negative 2, whereas my vertical asymptote is x is equal to negative 5. So I have those as well. Guys, this is what I need to be able to sketch. Okay, so let's go now and actually sketch these functions. So let's see if I can't get a pencil somewhere, because that is far away from me. Star Christie, be very careful. A is negative 1. The function is found in the second and the fourth quadrant. This function is an increasing function. Be very, very careful with that, what you've concluded about in the comment section. Right? We established this in the notes. We just came from there. Remember, we said when a is less than 0, the function is found in the second and the fourth quadrant. It's an increasing function because as x increases, y increases. X increases, y increases. Are you with me? So please, Star Christie, when a is positive, right, we established from the notes that it's a decreasing function found in the first and third. So you need to understand when a is positive, odd positions, odd quadrants, 1 and 3. When a is less than 0, even positions, quadrant 2 and 4. Okay. So let's come here. Let us Cartesian plane first. Roughly speaking, please guys, I'm drawing freehand right now, and I don't have the privilege of being able to use both of my hands because I'm holding one of my my other hand is busy with the phone. So please bear with me, but you would draw your y-axis and your x-axis, and you would do a good job in making sure that those are clear. Now, first thing we do is we sketch our asymptotes. Very important. We start there. We start with asymptotes. Okay. And I like the idea or the notion of starting with asymptotes. When when you establish something, you always try and set rules and boundaries from the get-go, because that gives people direction as to how to act, how to treat each other, and safety. It ensures safety for those that basically are in that space. So you must always establish boundaries first. That goes with even relationships that you have with others. You must establish boundaries. You must establish the do's and the don'ts. So we first write the asymptotes. Y is equal to -2. Where is y is equal to -2? Here, -2 roughly. Right, so I'm going to draw in a horizontal asymptote and then label it with my pen. Y is equal to -2. This is my horizontal asymptote. X is equal to -5 is my vertical asymptote. X is equal to who? -5. So let's just come here and say -5 is there. Then we come here and we sketch our vertical asymptote right there. Let's just extend this so that we can see a much more clearer vision of this sketch. Okay, it seems like this sketch is more towards this side. All right, so even when I drew my sketch, you know, yeah, I'm seeing the function, all right, already. Then I label my vertical asymptote. X is equal to -5. Guys, please make sure that these are horizontal, vertical indeed. You use a ruler so that it is straight. Very important. I'm drawing freehand, so much of what you see is based on this free-handedness that you see. Then, when I've labeled, this is a mark. Already I have one mark in the bag from drawing the asymptotes. Okay, and this is a three-mark question. So 1 out of 3 is better than 0. It's 33%, guys. And according to the government, that's a pass. But guys, please don't settle for that rubbish of a pass. It's a nonsense, that thing. It's not even a pass, that thing. Level 2. Guys. Stay away from such. So your vertical asymptote, your horizontal asymptote. Remember, what did I say? A is negative, which means the function is going to be found. I can already see my arm here, and then my other arm there. I can see him. I can see him. Now you go to your calculator and you check. -11/2, roughly where is that? So you use your calculator so that you can get an idea of the decimal number, because this will give you an idea as to where this is. -11/2. It's the x-intercept, where the graph cuts the x-axis. So -11/2 is -5,5. Thank you so much, Primrose. Primrose, you are such a star. So -5,5 is here somewhere. Hi, Primrose. Okay, thank you so much. So that's -11,2. So what you do is when you label it, right? I'm sorry. See, now I just have to. Okay. I wrote that -5,5 for the purpose of knowing where it is, because when I look at the fraction, I'm like, I have no idea where we're talking about. But at least when I see it with a decimal, I can see, -11,2. You label it. You mark it and you label it -11,2. Okay, very important that. Then let's go to the next point. -11,5. That's our y-intercept. So we are talking about here. Where is -11,5? According to the calculator, what's -11,5? I just need the value so that I can estimate. Is it here? Whereabout? Is it closer to -2 or a little bit farther away from -2? What's the answer? -11,5. If you press SD in your calculator, what is the decimal? Thank you, Dwana. Hey, Dwanas. Ndwanas. Ndwanas. Yeah. Okay. So I just use a shade to make sure that those points are marked. Okay. And then from there, this is what I do. Curve, my man. Curve. Curve, my man. Curve. Do you see that? Curve, my man. In this quadrant, through that point, curve, my man. It approaches this line, never touches, and I just draw an arrow to indicate it goes on forever, but never touches that line. And then here as well, I approach, but I never touch. I draw an arrow to show it goes on in that direction infinitely. Then we come to this side. Do the same thing. Curve, my man. Curve, my man. There, you see, approaches that line, never touches. Then curve there as well, approaches, never touches. Those are my asymptotes. Obviously, you see, I said this is my vertical asymptote, this is my horizontal. Okay, and based on where I was expecting to find my two arms, when A is less than 0, it means that my two arms are found in the second and the fourth quadrant. Remember, I found my x-intercepts. So what I did, I now marked my x-intercept. Okay? I hope you understand. I've marked my x-intercepts. There they are. Okay? And then my y-intercept, there it is. So I at least have a point for my second quadrant, and I at least have a point for my fourth quadrant. Okay, because my quadrants are defined by my asymptotes. DK, thank you so much for the 5 roses. My quadrants, okay, this here is quadrant 1. This asymptote makes it such that this quadrant 1 is all of this part. Quadrant 2 is all of this part. The boundary lines basically define the boundaries of the asymptote. So my first quadrant, second quadrant, third quadrant, fourth quadrant. Okay. Yeah. Thank you so much, Livia. Guys, Livia is phenomenal, by the way. Let me just say, if really and truly, maybe I'm not clear to you, please do make it a point that you guys connect in your various ways. And, after all, I value peer-to-peer. Sometimes peer-to-peer helps a lot. So maybe during the day, you guys can actually have a live session, and maybe you can re-explain some of the things. I do understand also it's early morning. Some people are really feeling sleepy, and maybe not everything is being grasped. So I understand that. But yeah. And DK as well is saying, can I join? Yeah, please guys, do those things. All right. This comes back to what that young man said, the one from Limpopo, forget his name now. But what he said was very key. The fact that they feel like they don't even need their teacher. I give you the wings to fly. You guys fly as high as you possibly can. DK, it's very important. And you can see even Livia is suggesting there that maybe you guys can create a group, and please go ahead and do that. Just make sure that, like I said, you establish boundaries, okay? We don't want other things happening that shouldn't be happening, all right? Boundaries should always be clear. I'm a big believer of boundaries, very important. I think it gives us liberty to be able to work and do what needs to be done, something that will be productive and which will help one another so that we can thrive in our academics within, like I said, boundaries. But please, guys, let's stick to that. And I think if you can do that for yourselves, that would be epic. So that when I do the live, it's more of like you guys are just polishing certain things. It's not like you largely depend on me doing a live in order for you to be doing something. Does that make sense? So I like the initiative in the comment section. Please go ahead, guys. Do what ought to be done. And please do report. I'd love to know what's happening and if you guys are having a successful time. You guys will be able to tell your own stories about the progress and the success that you've been able to meet because of collaborating and working together. Okay, so like I said, guys, that's my sketch. Asymptotes together, y is equal to -2, that's my horizontal, x is equal to -5, that is my vertical asymptote. And then of course making sure that I mark my x-intercept and my y-intercept. Fortunately, the x and the y-intercept actually are where the two quadrant arms, okay, respectively. I have at least one point for this arm to be sketched, and I have that point for at least this arm to be sketched. I know the shape because I expect and anticipate the shape in that quadrant arm, and then I know and expect and anticipate the shape for the fourth quadrant arm, and that's it. Okay? And then all you do is you label the function f of x is equal to -1 over x plus 5 minus 2. And then that basically, that is your sketch, and you get your full marks. Because what they basically want here, they want you to see that you understand the concept that when A is positive, thank you so much, Primrose, so much appreciated. They want to see that you understand the concept, okay? They want to see that. They want to see that you understand that when A is less than 0, the function is found in the second and the fourth quadrant. And that you can use then your x and your y intercepts to be able to locate at least a point so that your arm can be drawn in one of the quadrants. And then because your x and your y intercept exist respectively in these quadrant arms, then you can actually use those points so that you can anchor the function and see its shape in this quadrant. Please, guys, you see this curve smooth. This is not a straight, it's a smooth, nice curve. You can see it's approaching the asymptote, but never touching it. Even this side, it's approaching the asymptote, but doesn't touch. It doesn't turn back. No. It turns, it's a smooth curve towards the shape, okay? Show the shape of the graph. Yeah, definitely. A does that, okay? A gives us the shape of the graph and the position. Please, guys, two things. A gives us the shape and the position, because A will tell us that it is found in the second and the fourth quadrant because A is less than 0. But if A was greater than 0, it would be found in the first and the third quadrant, okay? So I hope that makes sense. Okay. Now that was nice, okay? And yeah, this question 4.5 says determine the equation of the axis of symmetry that has a gradient of -1. Now you see this one, you are already being told exactly which axis of symmetry they want. They don't want both, they want one. But they want the one that has a what? The gradient of what? Of -1. Okay, so that's a piece of cake. The template, remember the template that I spoke about? I said there's the template. You just take the denominator expression, you put it in brackets, you add the q, or you put the q outside, and then you put whatever the gradient is. If they ask for the negative gradient x of symmetry, you know it's -1, so they told you that it is -1, which makes life very easy. So let's check. Here is the denominator, it's x plus 5. So look at this, y is equal to my gradient, -1, in brackets, denominator, x plus 5. Outside, I'm going to write -2. Okay, I'm one step closer to the answer. So what I do is I distribute the -1 into x. -1 into x is -x. minus 1 into positive 5 is negative 5. Why can I do that? It's because negative 1 is a monomial, and inside this bracket there are two terms. So I can distribute these terms by multiplication to each term in the bracket. So negative 1 times x, negative x. Negative 1 times positive 5, negative 5. And then you put the negative 2 following the negative 5. After that, you can add the like terms. What's negative 5 minus 2? Negative 7. Negative 7. That's the equation of the what? Of the axis of symmetry with the negative gradient, negative 1. Done. Template. Guys, isn't the template beautiful? Just the template. No need for complicated stuff. Just the template. Guys. Template the life. Just template it. Don't complicate it. Template it. Don't complicate. Template. What if they had asked us for the positive gradient axis of symmetry? Let's just ask, I want to ask the last three questions. Please tell me what is the positive gradient axis of symmetry. Find the positive gradient axis of symmetry. I'm going to give you a chance to do these next three questions. I want the positive gradient axis of symmetry. Give me that. 2, I want you to tell me what the domain and the range of the function are. So I want the positive gradient axis of symmetry for this particular equation, particular function. 2, I want the domain. And 3, I want the range. Please give me the domain and the range and the positive gradient axis of symmetry for this function. F of x is equal to negative 1 over x plus 5 minus 2. Please, I want 1, 2, 3. So I'm going to give you 5 minutes, and then the person Primrose. Primrose is like, this is very this is my thing. This is kind of like my thing. I see you there, Primrose. Then I want the domain and the range thereafter. Olivia. Ooh, Olivia. I love the ingenuity there, Olivia, with the X and the small letter E and the big capital letter R. It's quite impressive, if you ask me. Then Spinara, you are missing just one aspect of it. Okay. Otherwise, the first part of it is fine. Livia has the full package deal of the domain, which is amazing. Okay, good job. I love it. Primrose, I hope you're good. I hope even Nombulelo, being the one, of course, that had basically asked questions on this, is actually finding it very nice and smooth to move. Okay, I'd hope so. Okay, and then I can see as well Primrose with the range. Livia has the full-on package thing for the range there. Full-on package with Livia. Do maths with Livia. Okay, very good, Livia. Very good, very good. Why as an element of r, y cannot be equal to negative 2. Ndwana as well has basically munched that up and supports that. Guys, I hope we're well. I really hope we're well. So with the equation of the x of symmetry, hopefully you saw the template. It's just the template, guys. Just the template. Positive 1, x plus 5 minus 2. We distribute the 1. We have x plus 5 minus 2. We add the like terms, x plus 3. So y is equal to x plus 3. That's the equation. And you guys did very well. Your domain, I love it. I love it for you. X is an element of R. X cannot be negative 5. And then lastly, y is an element of R. Y cannot be negative 2. So the inverse of positive 5, therefore the domain x cannot be negative 5. And then lastly here, for the range, y is an element of R. Y cannot be negative 2. Thank you so much, Robert. Oh my goodness, Robert. Thank you so much for the hot me. How beautifully random and welcome at 6 minutes past 3 in the morning, where sleep has fled and maths is ablaze. You know what I mean? Sleep has fled and maths is ablaze. Okay. Guys, how are we feeling? Do you think it's a good time right now to kind of end this live? How many of you still have petrol in the tank? I think that's the term that they would use. Petrol in the tank, or have we exhausted it and we would actually like say this was... I wish the cab continue. I really enjoyed the lesson. Oh, I wish we can continue. I see Primrose is like, I wish fuel is empty for Livy. Oh, shame, man. Yeah, well, we can cap it here. I think what I'm gonna do though is that as I cap it, let me leave you guys with a question that has to do with hyperbola. Half past 10. We'll start at 10:30 tomorrow, okay? 10:30, Star Christ. 10:30. Yo, sorry, not this one. Here we are. Fuel is full. So I just want to leave you guys with this. You can do it for yourself. Not now. Do it for yourself. There. Okay. Star Christie, it seems like cross-nighting is happening, you know, so it'll probably be from 10:30 up until, you see the time now that I'm going to be ending, 3-ish, or it'll just depend on how far people can go. So I'll start at 10:30 and we'll see how far we can go. Or you can just screenshot Primrose. Or you can just screenshot your Primrose, you know. Maybe a chance to copy may not fly, but you can, like I said, you can screenshot. This is from the Western Cape, you can see, WC, Western Cape vibes. Okay, no problem, Donna, you can. You did matric in 2017. Yeah, no problem, man. You can definitely inbox and let me know what you need to let me know. That would be epic. Guys, you've been a great audience and I really appreciate you a lot. You guys have been really awesome. Thanks. The marks, you see, Moss. Write down the domain of f. We have 1. Calculate the x-intercept of f. You have 2. Draw the graphs of f and g on the same system of axes. You know, yes, we'll continue with function Star Christie. There's a lot to be continued there. You see, 5 marks. See, then calculate the values of x for which f of x is greater than or equal to g of x if x is greater than or equal to 3 for 4 marks. So I want to have you do this one. There's another one I want to show you. So hopefully you guys have screenshot. I think what I'm going to do as well is I'm going to actually post this onto my YouTube. I'll post it onto the WhatsApp channel, right? The WhatsApp channel. The link is also in my bio of my WhatsApp channel. I'll post this on the WhatsApp channel, but I'll also post it on the I'll post it also on the TikTok page. Okay, here's another one. Yeah, well, since we on hyperbola mode, let's get it whilst we're here. Here's another one, hyperbola. This is from the Northern Cape. Northern Cape, NC, right? Northern Cape. Another hyperbola type. Yeah, I think we're trying to address hyperbola, kill it whilst it still has, life in it. We don't want to leave any stone unturned there with the hyperbola. Okay. Okay, so I'm hoping people have screenshotted enough there so that I can move on to the next thing. Okay, and then let's see. Okay, it seems like straight line and hyperbola really love each other. Yeah, I think most of these questions were integrated questions. Okay, let's just give you one more. Okay, I think this is also straight line and hyperbola together. Okay, thank you so much. You guys are really welcome. Okay, I appreciate the expressions of gratitude in the comment section. You guys are really welcome. You guys have been a great sport. You make it, I must say, I really enjoyed your audience. I really love as well the charisma and the positive attitude that you guys have, and also the prospect of actually possibly doing something which is outside what we are doing, maybe to assist each other, and to also support each other. If you are running a race, I often think of this Comrades Marathon that they just did not so long ago. I remember seeing the account of the guy who actually won the Comrades, and his club of fellow team runners that ran with him, that ran with him during the Comrades, because you know how clubs, some teams run as a club, and when they run in the Comrades, they all dress in the same sort of like running gear, and then they run as that club even during the Comrades, and they encourage and egg on each other. Obviously, amongst each other, you will know who's the strongest of runners and who has the potential to actually win the Comrades and so forth. But they support each other, and they kind of become fuel for each other. So if you guys can actually, like I said, from this live lesson, form a group on your own, and you guys can assist each other. I think the way you guys communicated in the comment section, that would be great. Collaboration is one of the 21st century skills that young people need to cultivate, because into the world we are stepping into, collaboration is a big thing. So working with one another and aiding each other is an important thing there, and you'll find that maybe you'll go far together than you will on your own. So I'm all for that. Okay, guys, till next time, thank you so much. Thank you for the love that you've shown as well in the live. Thank you for the gifts. I really appreciate one and all. And you're welcome. Cheers. See you again. Bye. Thank you, Salvin. Salvin, I will, like I said, the live lesson will be posted in the YouTube channel. I'm sorry if I wasn't, because I did quite a bit today. We did just as an overview so that you kind of know, because I know you actually did say you want to have an idea. today we looked at nature of roots with functions. So I started out looking at nature of roots, but I think it's better if you view the entire lesson, because I feel like I'll just be butchering it, because it will be summarized and it won't be summarized to specific points. But I did nature of roots. I unpacked what roots are, and then I also looked at what do we mean by their nature, in terms of being real or non-real. And then if we look at real alone, then rational and irrational will dictate, equal or unequal will further explain. And then we looked at the discriminant, how to find the nature of roots using the discriminant b squared minus 4ac, which is found underneath the square root in the quadratic formula. We actually did an example of x squared plus 5x plus 6 is equal to 0, where we were able to find or determine the nature of roots. And I explained this very thoroughly and in depth. Okay. Then we did further examples of how to discuss or determine the nature of roots without solving the equation using the discriminant. We looked at how a function looks like that is having roots that are equal, what that looks like. A function where the roots are non-real, what it looks like. Okay. Then we looked at type 2 of nature of roots questions, which have to do with solving for an unknown other variable. Okay, when we are given the nature of those roots. Primrose, please do watch. Like I said, I'll save this video. It will be uploaded onto my YouTube channel. Hopefully you have actually gone to my link in the bio. There are 2 links there. There's the WhatsApp channel, there's the YouTube channel. The YouTube channel is what you need to subscribe to, but the WhatsApp link is also helpful, because there I also post the links that are clickable of my YouTube videos that I upload. So you can be subscribed and actually connect to both. Then you can watch the video as I will post it. And you can, if you have any questions, you are more than welcome to contact me on the side about specific things that you would like to know or understand more about. Then, we did other questions, exam type questions, that were with regards to nature of roots. Then I turned my attention to functions. We did hyperbola functions. We actually explained the basics of hyperbola functions, what the form of the function means, a, p, and q, what they do, what they mean. And then we did a problem together, which you came in and we were busy doing it, right? Where we found certain aspects, and then I then concluded the lesson for today. But there's a lot of explanation given in the lesson itself, so that's why it was lengthy. And thank you guys again. Much love for all of you, and have a good one. And please, like I said, do make sure to watch the video when it's uploaded, if you missed this live. Cheers guys, bye.